In this beautiful Saturday, and I'm happy and glad to see you all here, and all those who are online, because I think the topic of the conference is among the most attractive what we can imagine today, and of course all we are facing. Aging and bad health and a lot of problems, but we will try to give you the second set of information. If you participated yesterday, to really to think about and to revise what you think about what did you think about the longevity and aging and most importantly healthy aging. Yuri?
Yep. So good morning to everyone, and this is my honor to invite Professor Valdis Pirags to present us his lecture, Can We Slow Down Aging by Restoring Healthy Psychoendocrine Regulation? Professor Valdis Pirags is one of the godfathers of Longevity Alliance Baltic, together with Ilya, and a well-known doctor physician in Latvia and beyond. And his main area of interest is, first of all, being a real doctor internist, being a therapist, being an endocrinologist, and he's also practicing the integrative medicine, which is actually unites all. So, Professor Pirags, the floor is yours.
Yeah. Can we slow down the aging by restoring of healthy psychoneuroendocrine regulation? Of course, this is a billion euro question, and I'm not supposed to give you the final answer, but I want to raise some ideas this morning, and probably it will lead to the thought process in your minds for at least some while. Okay. And today is Saturday, and in Latvian it's Sestdiena, and the sixth day is, according to the book of Genesis, is the creation of Adam. And creation of the Adam is not just a creation of the human being, but the whole humankind. And you see probably two most popular paintings by Michelangelo from early 16th century on the ceiling of the Sistine Chapel in the Vatican. And the second, of course, is the fall and expulsion from paradise. And in the context of our conference, I think it depicts the loss of immortality, the aging, and finally the death. So we shall think about two fundamental processes depicted by Michelangelo here. Interestingly, according to the Holy Bible, Adam was 130 years old man when Eve, his wife, gave birth to Seth, his first son. And Adam was 930 years old when he died. So probably those are the numbers we should consider if you think about, if we think about the how to prolong the healthy aging process. At least nobody believes in those numbers, but at least those are numbers we can consider. So the life is getting even more interesting if you think what is behind those very classical paintings. And the Meshberger, the doctor from, I think from Chicago, he was writing in JAMA, which is one of the most the most influential medical papers in medical journals in United States, that actually what you see on the ceiling of the Sistine Chapel is depiction of the human brain, and probably Michelangelo was thinking about the intellect, which is considered to be a product of the brain, to be a god. Another journal, European Journal of Endocrinology, published some years ago the very good article on aging and anti-aging concepts from the endocrinology point of view. And the main author was Professor of Internal Medicine and Endocrinology, Diamanti Kandarakis, and you may see here a very nice definition what is aging and how really we should consider it as a process of hormonal deterioration. Namely, aging is defined as a gradual, time-dependent, heterogeneous decline of physiological functions. And aging is orchestrated by a plethora of molecular mechanisms, which vividly interact to alter body homeostasis and ability of an organism to adjust to today's alterations, in conjunction with the dynamic effect of various environmental stimuli across a lifespan, promotes longevity, frailty, or disease. So longevity or frailty and disease are products of alterations of hormonal networks, and mainly the hypothalamic pituitary network. That is the statement from endocrinologists. So another variation of this famous Michelangelo's painting, here you see that the brain, if you plot it on this painting, becomes quite interesting. If the pituitary, which is here, and hypothalamus becomes really the important place on the god's body. So the main regulator of many processes, including the reproductivity and vitality and etc. There was a special issue of the journal Science last year, October, on the hypothalamus, and the characterization of hypothalamus in this journal was like a small and mighty. And indeed, a hypothalamus is a small structure deep inside the brain, and very conservative among species. So hypothalamus generally is very similar in all mammals, and the functions hypothalamus is regulating is highly conservative among mammals, and probably some other vertebrals. So then the bridge to the aging is quite obvious. The hypothalamus is the main control center for the vital functions. And as long as this command center works properly, we are living in relatively good health, and we are able to recover from illnesses, from traumas, from psychological problems, etc. So we need to understand how to restore and keep hypothalamus functions proper. But the main problem for the research is that hypothalamus is extremely complicated organ. It's not just one of many endocrine organs. It's composed of 11 nuclei, and they have many bidirectional connections with almost all neuronal and endocrine systems. Trevor Hancock is a Canadian scientist who is considered to be one of the fathers of the modern green thinking and philosophy. And probably this is another picture which is showing healthy and healthy person in harmony by Leonardo da Vinci from the end of 15th century. So the Renaissance men, and Hancock considers the trinity of body, mind, and consciousness as the cause of source of harmony and health, and then around this trinity there are all other events in our environment which are interacting with our body, mind, and consciousness, including family, society, culture, individual biology, physical environment, psychosocial environment, and the behavioral model of the individual. So endocrine system, as I said, is mainly regulated by central control center, which is called hypothalamus. So the key question is, could we, today in my lecture, is can we somehow prevent or control the alterations in hormonal network caused by aging and environment? And I took some very complicated slide from the journal Signal Transduction and Target Therapy, and the authors are trying to show all possible approaches how to slow down the aging and aging-related diseases, and only 2 hormones, and I showed it in this red circle, liraglutide and semaglutide, of course, are belongs to the strategy of anti-aging. And I want to say it's too little because probably we have to consider not just incretins or gut hormones as liraglutide and semaglutide, GLP-1 receptor agonists, but the whole system as such, the whole neuroendocrine system as such, which could be influenced to slow down the aging. So back to sources again, and Indian traditional medicine is based on 2 ancient textbooks, and one is called Charaka Samhita. And interestingly, this definition of healthy life is still valid. And he wrote at least 2,000 years back, it's documented, the healthy life has 3 main pillars: a balanced diet, proper sleep, and healthy sex and marital life. 3 pillars. And I'm wondering, do you agree with that? Most of people agree, but how really to keep those 3 main pillars functional? Let's start from the third one, reproductive life. And everybody knows that we are going through certain life cycles, and starting from the prenatal or gestational age, when we are still in the mother's body, and then during infancy, childhood, puberty, and finally there is a long period of adult reproductive period, and unfortunately it's limited by a certain age, most obviously, of course, in women when they are reaching menopause, but also in men. And after this comes the senescence period, and sometimes rapidly, sometimes very slowly, there are changes in the hormonal network, which leads to the frailty and disease and death finally. So it's obvious that we are going through those hormone-driven change throughout our lives. And there is no surprise that in hypothalamus, among those 11 nuclei, 2 of them, preoptic and anterior, are directly involved in sexual behavior regulation. And interestingly enough, there is an overlap with thermoregulation, which also deteriorates with the aging. If you remember your childhood, the thermoregulation was completely different as you feel today, probably. Then healthy sleep cycle is another very complicated object, and I will not try to read those very small letters you see, but in fact it's not so important what is written here. You have to understand that this cycle of sleep, healthy sleep, is one of the pillars of recreation. And the so-called inhibition period, actually during the sleep, is not just blackout. It's a very productive period for the rejuvenation and restarting of many our internally regulated systems. So finally, the hypothalamus is involved in the regulation of appetite and energy balance. And the drugs which actually created Novo Nordisk as the richest pharmaceutical company, this is the event of very much surprise in the last years, thanks to semaglutide, is about this. So, incretin hormones, including GLP-1, is regulating our appetite and energy balance, and those hormones are secreted from the gut. And the gut is actually a big sensor organ, big endocrine organ. And the physiology is that after you eat, there is a period of time which is necessary for the food to reach those cells. So, and only when they are activated, you feel satiety and you stop eating and you are happy. So unfortunately, with the age and psychosocial problems and stress, people are losing that healthy regulation of satiety, and incretins in supraphysiological concentration are stimulating those hypothalamic cells, which are creating again artificial or natural for obese people, restoring the natural cycle of satiety. So this is a very simplified explanation why Novo Nordisk is so rich. So losing of weight and restoration of the normal homeostasis of appetite and satiety regulation leads really to metabolic improvement, and metabolically healthy people are more happy and definitely are living longer and healthier life. And this is the story about microbiota. And microbiota, the metabolites generated by microbiota are promoting GLP-1 and PYY production from intestine L cells, as I explained previously. Yeah, there's a difference between metabolic homeostasis and metabolic syndrome, and in fact, more than half of people have a metabolic syndrome, which is connected with increase of inflammation, cytokines, and dysregulation of cardiovascular system and immune system, etc. So my conclusions: changes in homeostatic processes such as sleep, circadian rhythms, and body composition are hallmarks of aging, and we can prevent it. Aging is accompanied by alterations to body composition, including abdominal obesity, etc. And there is a decline in basal metabolic rate and total energy metabolism, and we can regulate it by influencing our hypothalamus. Older individuals have a decreased average internal body temperature, which is actually also the result of hypothalamic dysregulation and circadian rhythm disturbances. And it leads also to susceptibility to infection. And as you know, elderly people also are suffering from the disturbances of sleep-wake cycle, and therefore they are prone to develop different problems and are not able anymore to rejuvenate properly during the sleep time. Thank you so much for your attention.
Professor Pirags, thank you so much for the presentation. And we have actually 1 minute for one question to ask regarding this topic. So may I ask you, please, what is, as an endocrinologist, what is your suggestion for therapeutic intervention in hormonology, in hormonal therapeutic intervention that might be beneficial for the healthy, promoting health and longevity?
Yeah, the incretin hormone intervention, as I mentioned several times, for the body weight and metabolic syndrome regulation, and then of course the healthy, let's say, reproductive life is also extremely important to keep your gonadotropic hormone axis functional as long as possible. So those are, I think, the most obvious interventions we can think about.
Thank you.
So then my privilege is to introduce to you Professor Marek Postula. And his topic is partially also connected to endocrine system. And he will speak about geroprotective potential of SGLT2 inhibitors, widely used in treatment of type 2 diabetes, but recently they became major drugs, major drug class for cardiovascular medicine and kidney medicine, etc. Professor Postula.
Yeah, hello, everyone. Hello, Professor. Thank you for inviting me for this excellent meeting. You know, it's my privilege to be here with you in beautiful Riga, and I'm amazed about the library you have. And I'm sure if your healthcare system looks like this, the longevity is full of success in Riga in the future, in Latvia in the future. But I would like today to continue a discussion that we started yesterday with near Barcelona about potential geroprotective drugs. And as you can see, my topic is about the SGLT2 inhibitors. So yesterday we mentioned why potential SGLT2 inhibitors may be beneficial in longevity. So I would like to deliver you today some more information on this topic. I will dive deeper into this topic. But before that, let's start from the history. So history of this molecule started a long time ago in 1835. Two French chemists discovered fluoresceins, which they discovered them in the bark of the apple tree. And it took us decades before we fully understood what is the mechanism of action, behind glycosuria induced by those molecules. And thanks that we discovered that the key molecule behind it is a co-transporter of sodium and glucose, known as SGLT2. But before it entered pharmaceutical market, most of the research were based on these pharmacological properties. And in 2012, for the first time, the first fluorescein, or the first SGLT2 inhibitors were introduced into the market, and it was canagliflozin. Then 1 year later, in 2013, another SGLT2 inhibitor, dapagliflozin, was approved by FDA. And in 2014, finally, empagliflozin was approved by FDA. Why I'm mentioning it? Because it's not a long time ago. We were talking yesterday about metformin, which is on the market more than 70 years. And we have to be aware that our expertise and our knowledge on SGLT2 inhibitors is kindly new. But the golden era of those drugs started in 2015 when the EMPA-REG outcome results were released. And actually, it started from the results of this trial that were done in type 2 diabetes patients. Since that, many other clinical trials were released, and you will see that actually this is what we were waiting for a long time, to find finally the drugs that may prevent some diseases related with aging. But of course, right now we understand that clinical effectiveness of SGLT2 inhibitors is far behind SGLT2. We know that those drugs can decrease renin-angiotensin system activity. They can decrease sympathetic nervous system activity. But what is the most important to remember, that the clinical effectiveness is most probably related with its anti-inflammatory and antioxidative properties. But what about clinical proofs? Because when we are talking about drugs in the longevity anti-aging medicine, we have to find the clinical proof. So let's move back to the era before statin. So this is the results from 4S study with simvastatin. And as you can see in cardiology, we are using several metrics to understand the effectiveness of the drug. And one of the endpoints that we are using in cardiology is called MACE, which is translated into major adverse cardiovascular events. And usually it's a composite endpoints, including cardiovascular death, non-fatal myocardial infarction, and non-fatal stroke. So in this term, when we understand this definition, and we can see on this number, which is number needed to treat, which means that we need to treat 30 patients to prevent one MACE, which was defined as I previously said. So you can see that in the 90s, we had to treat 30 patients for 5 years with simvastatin to prevent one major cardiovascular event. Then in 2000, we released the result of HOPE trial with ramipril. And as you can see, the number needed to treat for ramipril, which is currently a pillar of many therapies in cardiology, was 56. So it means that we had to treat 56 patients to prevent one major cardiovascular event. And right now we are approaching to EMPA-REG outcome results, and as you can see, for empagliflozin, but what is very important to mention here, that we already, in this population, this very high-risk population of patients included to EMPAREC outcome trial, we have patients that were already taking statin. They were already taking ACE inhibitors, so actually we have completely different population that was included to 4S study or HOPE trial. So you can see that number needed to treat for empagliflozin is 39. Of course, we were expecting better number, but look on the number. We were using in this trial empagliflozin only for 3 years, but when we will extend it to 5 years, the number needed to treat decreased to 25. So this is one of the examples how we can understand current knowledge, because of course, comparing old trials like 4S, HOPE, or even trials with metformin is like comparing Niki Lauda to Max Verstappen, you know, the Formula One drivers. Of course, we can't compare something what is old. Of course, I'm not sure whether Niki Lauda would win any race with Max Verstappen currently, most probably not. But of course, we will never find it, but we can find which drug is better, whether metformin or SGLT2 inhibitors. But we have more proofs for SGLT2 inhibitors. Of course, all of these proofs comes from clinical trials that we already know, and we have a clinical trial for empagliflozin, but not only for empagliflozin, but also for other flozins, but I will focus on empagliflozin. So you can see here that we have data from EMPEROR-Reduced trial with patients with heart failure with reduced ejection fraction, and number needed to treat in this very high-risk population of patients is even lower because it's 19. When we look on another trial, EMPEROR-Preserved, the number needed to treat is 31. Of course, it's lower because you have to remember that heart failure with preserved ejection fraction is actually more common and more severe condition, so we can't expect the same number needed to treat. And when we think about longevity and about the patient that we would prescribe this drug, we can say that most of patients with obesity or obesity phenotype is equal to heart failure with preserved ejection fraction. So actually, we can start a discussion with Nir that he started yesterday, that when to start and for who to start SGLT2 inhibitors in longevity. Okay, but it's not the final knowledge about SGLT2 inhibitors, because we also know that they are very effective drugs in prevention of renal endpoints, and we have 3 different clinical trials, so we can say that we have a class effect of this group of drugs. So we can see that they can prevent progression of chronic kidney disease, and when we look on HR hazard ratio is almost 30, so they decrease the risk of CKD progression by 30%. And of course, what is also very important when in terms of longevity, we have data that they may prevent diabetes in patients with pre-diabetes condition, and this data comes from meta-analysis that was done based on data from DAPA-HF and DAPA-CKD trial. As you can see, when we only look on dapagliflozin, this hazard ratio is lower than when we include other trials with empagliflozin. But of course, this is another proof that actually those drugs are very good drugs for prevention. And another important pillar of aging is, of course, dementia. This is a huge problem increasing in Western countries. And again, we have solid data that were published recently. And in this meta-analysis, they included more than 400,000 patients. So this is a huge analysis showing us that potentially SGLT2 inhibitors may prevent dementia, because we already know that SGLT2 is expressed not only in the kidney, but me and my team, we did an in silico analyzing using some available expression data, and we found that, and we confirmed and we published those data, that SGLT2 can be found not only in the kidney, but also in the liver, in the heart, in the muscle, and also in the brain. And we know right now that SGLT2 inhibitor can cross blood-brain barrier, and they can potentially inhibit SGLT2 within the brain tissue as well. Okay, and what is also very important, we were mentioning it, about it yesterday, is the physical activity. So you know this picture showing that potentially metformin is a drug that shouldn't be taken by physically active people, I mean sportsmen who are in the training and they want to compete in the competition. And we are searching for a miracle drug that would actually improve or would add to benefits related to physical activity something. And what you can see here about SGLT2 inhibitors, we still don't have a solid data. I can't tell you that this is the drug that all sportsmen should take to improve their VO2 max or cardiorespiratory fitness. But we have a data for empatropism trial, which are given here. And empatropism trial was done in patients with heart failure. And what you can see here, in those population of patients, taking metformin may improve VO2 max, which translates into better cardiorespiratory fitness, which in this specific population of patients is very beneficial. Okay, and the fundamental question whether those drugs can improve lifespan. And of course, yesterday, Nir shared with us those information. And of course, we have some data from trials on animal model. And yes, they may increase lifespan. We have animal model, of course, only in male model it was found. They may increase lifespan by 14%. And of course, animal model is far from human being, but what we have found in empiric outcome analysis, I must remind you that it's only on type 2 diabetes patient. When we look carefully on the data from this trial, we can see that taking empagliflozin starting at age 45 may increase the lifespan by 4.5 years, which can be translated into increased life expectancy across all ages from 12 to 15%, which is very equal to those results that we found on animal model. And of course, when we have some clinical proofs, but beside that I'm a cardiologist, I'm a sport cardiologist, I'm also a scientist, so I'm always trying to look on the problem from different perspectives. And my perspective, my scientific perspective, focus on these hallmarks of aging. And of course, we saw yesterday that if metformin is able to interact or can change these hallmarks of age, all 12 hallmarks of aging, we have similar data for SGLT2 inhibitors. And when we look closer into molecular mechanisms of action, we can see that on cellular levels, SGLT2 inhibitors, they mimic caloric restriction condition. So caloric restriction condition switch on this catabolic state, and as a result, we have increased activation of IAPK pathways, we have decreased activation or deactivation of mTOR pathway, and as a result, as you can see, we have increased expression of sirtuins, which are very important molecules that are responsible for healthy aging, but also for mitochondrial function, and it translates into improved ATP production, cytoprotection, and of course decreased cellular stress and inflammation. So, but I don't have time to discuss all of the pillars of or hallmarks of aging and the impact of SGLT2 inhibitors, but my team focused on these epigenetic changes. And first, we started from building a network analysis that allowed us to better understand, it was published in 2022, it allowed us to better understand the interaction between gene encoding SGLT2 with other genes. And as you can see, we found on the first level of interaction that SGLT2 inhibitors increase the expression of these glucose transporters, also sirtuin 1, and also insulin and DPP4, which is dipeptidyl peptidase enzyme. So it was the first finding from this publication, but we also confirmed that SGLT2 inhibitors are potent drugs that can affect on MPK and mTOR pathways. We also ask to our biostatistician, bioinformatician question, how about inflammation, how about oxidative stress, all of these processes related with aging. And as you can see, we have a very solid data from gene expression analysis that yes, SGLT2 inhibitors may change gene expression in pathways related with aging, with longevity, with inflammation, oxidative stress, and autophagy. But of course, when we think about epigenetics, we are thinking about DNA methylation, and we have initial studies on DNA methylation that were done on animal models and on cellular lines. And as you can see, in this experiment, we found, it was found because it's not our study, but it was in this nice paper, we can see that this hypomethylation induced by hyperglycemia in the gene encoding superoxide dismutase and NFK beta, you can see that potentially those drugs, they prevents this hyperglycemia-induced hypomethylation, which can be translated into this anti-inflammatory and antioxidative effect. But our team, we are highly interested in microRNA. This is another epigenetic area, and we did a literature search and we published a review paper on this topic, and we focus on potential impact of SGLT2 inhibitors on different microRNAs, and you can see here different models, and we found that there are already papers released on this topic, but we also built our own network. We wanted to understand which new microRNAs could be potentially regulated by SGLT2 inhibitors, and microRNA as a regulator of gene expression may regulate other gene and other processes. So, but in our latest work, we focus on sirtuins because, as most probably you all know, sirtuins are also molecules that we are really interested in the longevity sector. And of course, what we started from this analysis searching for potential microRNAs that are regulating sirtuin expression. So as you can see, we found, based on this in silico analysis, we found 6 of them. And in another study, and as you can see, the data are not published, so you are the first audience that can see those results, because it was analyzed before coming to Riga this week. So we used samples from Emil trial. Emil trial is a trial that was done in patients with myocardial infarction by our team members from Graz in Austria. So you can see that when we look into microRNA expression, potentially related with sirtuins, we can see overexpression of those microRNAs after 26 days of treatment with empagliflozin. Of course, when we dive deeper into the knowledge about those microRNAs, it's not a very positive information, but we have also placebo group in this trial, and we couldn't prepare the presentation for this, but when in placebo group, we have even higher expression, so we can hypothesize that potentially SGLT2 inhibitors may increase those harmful microRNA expression. And we also, in the same Emil trial group, we checked expression of sirtuins. And what is very important, we couldn't find changes in expression of sirtuin-1 or sirtuin-3, which are mechanistically related with SGLT2, but we found a very interesting result that potentially in the empagliflozin group, we have higher expression of SIRT6 and SIRT7, which are expressed only in the nucleus. We don't know how to explain it because we didn't have time to check the literature, but potentially this is something novel, and we will go deeper into this topic. Another thing that we would like to do in the future, we are collaborating with McMaster University, and we are in the process of DNA methylation. So another results that we will release very soon will be on DNA methylation upon SGLT2 inhibitors therapy. Okay, so when we are thinking about geroprotector, so geroprotector is the drug that aims to affect, of course, roots of aging, but also it may affect age-related diseases and also prolong the lifespan. So I think that we have no doubts that SGLT2 inhibitors are very good candidates for being a real geroprotective drugs. Yesterday we saw this table prepared by Neil Bartley and his team, and you can see that even such a distinguished professor who is working on metformin since many years, he put in his ranking on the top level SGLT2 inhibitors as a potential #1 geroprotective drugs. But of course, when we look on our current knowledge, we have some data from in silico and in vitro studies. We have some data on animal models, but still we are missing some human studies. And I believe that in the near future we have maybe not a tame trial with metformin, but we'll have a similar trial with SGLT2 inhibitors that we will analyze, and we'll have a solid clinical data whether they really can extend life not only in patients with heart failure, with diabetes, but also in healthy individuals. So all of this work was done with my ICOMET team. Here you have some representative of my team. And also we are working on the very nice topic when we are talking about longevity. I would like to share that we are also working on the topic of physical activity, and we want to do this multi-omic approach, and based on this multi-omic analysis, we want to personalize physical activity, which is the best intervention for aging. So if you are not physically active, I recommend you not to start from SGLT2 inhibitors, but start from being active, because this is the most potent drug that can inhibit mTOR and improve AMPK that way. Thank you for your attention.
Thank you so much for this very interesting presentation. And can you explain me why such a simple sodium glucose transporter became so important? And what is the mechanism behind those pluripotential effects, actually, instead of what we expected initially? Because I remember the first trials, I participated with SGLT2 inhibitors in diabetics, that it's just will increase the glucosuria and decrease the blood glucose. But it turned out that it's much more complicated, actually. But what is your simple explanation why it became so?
Yeah, actually, the
molecule.
You know, of course, it's a very good question, because we don't have clear answer. We're still working on the precise mechanism. But I believe that the very simple answer is anti-inflammatory potential. This is the key factor that, because when we look on any model, because we tested them on diabetes, we tested them in heart failure, kidney disease, of course, on liver disease as well. Alzheimer's disease, Parkinson's disease. So all of this, what is in common for all of this disease inflammation. So I believe that all drugs that have any anti-inflammatory potential may improve those conditions. And we have the same result for GLP-1. Recently, there was a paper, very nice paper with GLP-1 in Parkinson's disease, that they can prevent early movement disturbances in Parkinson's disease. And it is believed that this central anti-inflammatory action or neuroinflammation inhibition is the key answer for example, for those patients. So I believe that the same we have with SGLT2 inhibitors. And in my opinion, in the future of longevity or anti-aging drugs will be combination of SGLT2 GLP-1 and maybe some other molecules, because we have so many different molecules under investigation in different clinical trial phases that next decade will bring on something that at the moment we can't even imagine. This is what I believe.
Thank you. Any other questions?
Let's ask the audience. Yeah.
Sorry.
Tell us, please, some word about methylene blue.
You know, actually, we discussed about methylene blue yesterday, so I believe, you know, yeah, so to be honest, I won't add anything more about methylene blue, so because, you know, this is not the field that I'm interested in, because, you know, we don't have solid data for this compound. So.
Another question? No, I will go there.
Thanks for a great talk. The SGLT2 inhibitors are also associated with increased things like urinary tract infections, other infections as well, which maybe goes along with your anti-inflammatory hypothesis about how it works. I'm just wondering, how does that fit into care for people, say, in nursing homes or other applications? Do you think it's sensible to move it into that, or do you think that it's probably better used with younger people to prevent them getting into that situation already?
Yeah, you know, side effects related to SGLT2 inhibitors, of course, are common, but according to latest analysis, it's more common in patients with diabetes. So this is obvious because, of course, we have a recommendation for patients on SGLT2 inhibitors is, of course, hygiene. So this is what we can recommend and what we are recommending to our patients. And from my clinical perspective, it's not a very common problem. So of course, it occurs in some patients, so I have to stop SGLT2 and find another solution especially for patients with type 2 diabetes, but it's not a big issue in my opinion. Of course, we were also concerned about potential risk of some urinary tract cancer, because we had some data on dapagliflozin, and it was actually the issue that we were trying to understand whether this higher concentration of glucose in the urine can promote cancer within urinary tract infection. But some further data didn't confirm that, and of course I couldn't present it right now, but we have also results from many trials, from many animal models, and of course human models as well. It was presented here on this slide with microRNAs, that actually SGLT2 inhibitors in some types of cancer may have preventive effects. So this is also very important, that they are not only this metabolic drug, but through this metabolic effect, they can also prevent some types of cancer. So this is also what we should keep in mind, that they are not simple anti-diabetic drugs, but also their effectiveness is far beyond this SGLT2, so what was discussed today.
So thank you so much for your presentation again. And
okay, thank you very much.
And we shall move forward, and it's my pleasure to introduce to you the presentation of my co-chairman, Yuri Ostrinski. And I don't know how to present you. You are Latvian-Israeli or Israeli-Latvian? Latvian-Israeli, and this is a good example how really to collaborate between different academics. And Yuri will talk about physical exercise as a target at healthy longevity intervention. Yuri.
Thank you very much, Professor Pirags. Yes, so we will start my presentation. Okay, so thank you very much for coming here and enjoying these very important talks on very important field of promoting healthy longevity. So the title of my talk is a targeted physical activity as a therapeutic strategy for a healthy longevity. So I have nothing to disclose, and let's speak about why we do it, why we do need a healthy longevity. So actually, as the previous speakers already told us, we are able to live for a long years. Let's say in Bible there is a 120 years, but we want to live it in the good health. So how we can do it? What is actually the healthy longevity? The concept is quite well known, but let's come over it again. So typical aging process in nowadays is accumulation and gathering of multiple chronic diseases. So as older we get, as sicker we become. It's like, you know, we have actually most prevalent option is assisted life support, but we want to make actually a joyful and productive life on the other side. So healthy longevity focuses on extending life while maintaining good physical health. And it also aims to ensure a longer healthy lifespan and while maintaining a good also emotional and psychological health. It also emphasizes the importance of a high quality of life as we live, as we age. And it strives for a balance between lifespan and healthy span. Now, longevity is actually an interplay. Yes, it's influenced by complex combination of genetic, environmental, lifestyle, and healthcare factors. Genetic factors, actually, this is a network of choices, and we sometimes hear that genes are everything, but actually genes, this is a network of choice, and it's responsible only for 20–25% of the entire outcome, 15–20%. But the triggers which promote some gene to be turned on off, called epigenetics, are the major player in what will be the outcome. So the lifestyle choices includes diet, physical activity, smoking, alcohol consumption, sleep patterns, and they significantly can impact our longevity. For example, a balanced diet, regular exercise, avoiding tobacco and excessive drinking will promote a better outcome and more a healthy lifestyle for the person. In opposite, those who smoke, who drink too much, who does not exercise, they risk themselves in being bedridden and getting quite soon to a life-supported existence, I should say. Another important player is healthcare access. We will see an example of statistics between two countries, which will be uncovered later, as a wonderful example of how important the healthcare quality and access. Of course, the environmental factors are very much important, and psychological factors are important. Happy people live longer. If you are an optimistic person, so most probably you will gain another few years for your happy and healthy life. So let's also have a look on the benefits of the longevity. So healthy longevity is just about enjoying your life, enjoying and living it fully. Healthy longevity gives us an improved quality of life. It reduces healthcare costs, and this is specifically interesting. Again, we will expand it later. It increases productivity. And of course, it enhances our cognitive functions. So this is kind of closed loop. We want to enter this closed loop because one thing maintains another one. Let's have a look on the longevity statistics in Latvia. Amit last day was already uncovered in us these surprising numbers, and as she emotionally was speaking, she was shocked. So indeed, the situation is quite interesting, I would say, and complicated. So the average life expectancy in Latvia as a statistic for 2022 was 73 years, well below the European average. While the gender gap is huge, it's 10 years between Latvian male and female. Male in Latvia unfortunately dying very, very early, and this is a very bad situation. We will speak, you can see also another parameter which is very much important about the effectiveness of healthcare system is the preventable mortality. 364 preventable deaths is a huge number. Yes, those are people who with proper medical treatment would live for another many years. Now, another very important data and measurement for the economy and healthcare is healthy life years at birth. So actually, this is a number of years when a person is relatively healthy and does not consume a lot healthcare expenses, and he feels good, you know, he thinks himself or herself as a healthy person. So in Latvia, this average length is only 53 years. Remember this number. Now, let's take another country, Israel. Israel is a very interesting country in terms of, first of all, people in Israel and Latvia has no difference in, you know, environmental factors. In Israel, people live in a very stressful conditions, but life expectancy in Israel is 83.4 years in average. So we see, yes, the jump of almost 10 years between Latvia to Israel. And preventable mortality is only 83 cases per 100,000. And this is a huge difference. And this number actually shows us the difference in a healthcare system, because healthcare system in Israel is not, you know, people in Israel has some specific genes, maybe some, but the main reason for this long life is primary care in Israeli medical system, actually. We will not expand too much, but those are very interesting numbers. And of course, the average healthy life years at birth in Israel is quite huge, 72 years, comparably to 52 years in Latvia. And this is a magic number because this is actually a measurement for also the economical performance of a country. And we'll see some numbers which are very, very interesting. So, how much cost adding one healthy year of life for elderly individual? And we will make I've made some analysis with the help of ChatGPT actually on the average Baltic country or Latvian-like country. So a few assumptions, you know, you can see, I will not read it, population similar to Latvia plus minus, the percentage of elderly population, etc., etc. So to make a long story short, the benefit, net annual economic benefit for a typical Baltic country for adding 1 year of healthy life is 3.6 billion euro yearly. You know, we hear here in Latvia that we lack some funding for very important projects, but investing a few tens of millions euros to proper healthcare will bring enormous payback. And by the way, in the global economy, this benefit of adding 1 healthy year to entire population is huge. It's 6.5 trillion euros annually. So we are quite convinced that health and longevity is not only desirable in terms of you know, subjective feeling, but it's also money-wise business, at least. So the current most promising strategies and intervention for health and longevity are multiple, actually, and some of them already well discovered in the previous talks. First of all, is a caloric restriction and intermittent fasting. Those who eat less lives longer lives. Physical activity is a magic player, and we will see it later on why. Senolytic drugs, NAD plus boosters, metformin, the magic metformin, which was so extensively discussed this talk, this conference, and of course the high-tier players like gene therapy and CRISPR techniques. Now, in the following slides, we will explore the potential of physical activity to manage healthy aging. Actually, this is quite under-researched, systemic and cost-effective tool for promoting healthy longevity. So let's have a look on what is the physical activity. Actually, physical activity is every movement that you do. It includes exercises, walking, making some garden work, but not every all exercises are physical activity, but not all physical activity counts as exercise. So the benefit of being active extends very wide and beyond, it includes actually the promotion of heart health, promotion of our body composition, our mood and mental health. It also makes a huge work and difference on our immune system. So let's have a look on the another slide. This is actually explanation on the, how physical activity works on the molecular way. So mild to moderate exercise promotes healthy longevity through the mitochondrial biogenesis. It actually stimulates the production of new mitochondria within cells. It also makes a telomere maintenance. Physical activity, regular physical activity, is linked to longer telomeres, the protective caps of the ends of chromosomes. Physical activity also induces autophagy, a cellular process that removes damaged components, promoting repair and maintenance of the cells. It has a strong anti-inflammatory effect. It modulates the production of myokines, this type of cytokines, and other inflammatory molecules, and reduce the chronic inflammation. It also improves the insulin sensitivity. So it also acts as an anti-diabetic drug or action. In addition, physical activity also makes a controlled stress on our body. And this controlled mild stress improves the hormesis as well. It acts as a hormesis. Okay, the next slide is about what we can do to make it more effective and precise. So I'm going to introduce the new approach, which we call a targeted physical activity. Just a moment. Yes, so targeted physical activity. As we have already said, the aging process is a kind of multifaceted chronic disease. And when it comes to manage chronic and other diseases, one size does not fit all. Maybe you know the joke that when a soldier comes to in army to the doctor and he complains on a headache and a stomach pain, a doctor gives him a very important drug, paracetamol pill, split it in two parts and say, you know, this part is for your headache, and another part is for your stomach, but do not mix up the medication, yes? So this is exactly the description of the generic approach to the physical activity nowadays in the disease management. Here we need to introduce the disease-targeted physical activity. Now, imagine yourself prescribing to your patient a disease-specific exercise regimen which is tailored for predefined patient subgroup. It's based on disease characteristics, specificity and severity of symptoms, physical capacity, age, and other clinical parameters. In our system, we create physical exercises sets that can have a positive benefit, positive effect on specific clinical condition, chronic disease actually, or on several conditions that have a common features. Through questionnaires and physical examinations by a trained physician, we can categorize our patients into subgroups to prescribe the most effective and safe exercise regimen for their specific clinical condition. This is when we implement actually the targeted approach. So these sets of exercises are built in such a way that they also provide the gradual increase of the intensivity accordingly to the improvement of patient condition. The main point is that the patient performs those sets within his or her comfort zone, and thus improving the sustainability of this intervention. So actually, we propose the precision medicine in action, but applied to the physical activity. In the next slides, I will present the example for such an approach and results on a pilot study on the disease-targeted physical activity as a therapeutic intervention for inflammatory bowel disease. So, this pilot study was conducted in Ichilov Medical Center, Tel Aviv, and it was a prospective, randomized, controlled, double-blind cohort pilot study when patients followed a daily exercise regimen, 5-6 days a week for 4 weeks. So what is interesting, we have divided this group into two actually intervention groups. One is yoga-based, abdominally targeted physical exercises, 3 types of them, 3 sets, 10 to 15 minutes long each set. And another one was this simple general physical exercises, and it was a placebo group. At the end of the intervention, I'll come to the result. This study, by the way, was already presented a few times, 3 times in the last year in the biggest conferences in Europe and in the United States. So the results are very much interesting. At the end of the intervention, clinical score improved significantly in both groups compared to baseline, but in the intervention group experienced greater improvement than the control group. More interestingly, the calprotectin, this is a marker of bowel inflammation, and this is actually gold standard for evaluating IBD patients. So calprotectin level decreased in the intervention group while it increased in the control group. By the way, most of you may know that physical activity per se can be, if it performed in the not right proper, so it can also create a damage to your health. But here we see that change in calprotectin was significantly different and better in the intervention group. So those results are very interesting because it actually gave us maybe in the first time, for the first time, the usage of physical activity as a targeted therapy, and it worked. So we want to expand this approach, this study, to additional chronic diseases like chronic fatigue syndrome and long COVID, and also for fibromyalgia. We already plan to conduct the studies here in Latvia, in Riga Stradiņš University, also in Paul Stradiņš Hospital for IBD. Yes, we open up the bigger study for IBD patients here in Latvia. And of course, our idea is that this type of approach for targeted physical exercise can be very much applicable and beneficial also for promoting healthy longevity or battling with aging, because aging, as today, as we mentioned, is a chronic disease. Okay, so about conclusions and recommendations. So as we have mentioned and as we have seen in our presentation, in my presentation actually, promoting healthy longevity is a multifaceted, it requires multifaceted approach. First of all, healthcare system counts a lot, and we have seen the difference in the statistic between Latvia and Israel. Public health policies, prevention programs helps very much also for allowing people to live longer life. Health literacy is very much important. We speak about very nice things that health and longevity is very much important. But if you come outside to the average person in the street, so first of all, I'm doubtful that many of those people know what is the health and longevity. So health literacy is one of the key factors for promoting health and longevity. Education is very much important. Of course, nutritional awareness is important as well. And the new player that we have introduced today is a targeted physical activity that can be very beneficial aid. It does not replace medicine, it does not replace medication, but in terms of cost effectiveness and holistic approach, it can make a very, very, very big change. And of course, those who try on themselves and those who promote it to others, primum non nocere, first of all, do not harm. So, thank you very much for your for listening to my presentation, and I wish you to live a long and healthy life. Thank you very much.
Thank you for this very interesting overview, especially about the yoga. And by the way, on 21st of June, we will have our International Yoga Day celebration not far from here in the university campus.
I take liberty to attend, okay.
Any questions to Dr. Ostrinski? Let me start. You have a privilege to compare, as you showed, Israel and Latvia in terms of healthy lifetime, etc. And the most striking, I agree, is the difference between the life expectancy in women and men in Latvia. And it's obvious probably target to increase the healthy lifespan in Latvia. What is your advice? How to increase the lifespan in men in Latvia? What are your observations?
It's an excellent question, which bothered me for the last 1 year, as you know. And the main arm for making a change is actually to introduce specialized programs for primary health care. Here in Latvia, one of the major players for this excess mortality is a very high percentage of cardiovascular events in Latvian population. It is enormously high, and we currently discuss with the Ministry of Health on introducing multi-professional program which will first of all screen Latvian population for these people in risk who are actually, as we spoke with your colleague from Paul Stradinch University, Professor Stradinch and Professor Eglis, they state that, and they are right, that more, if you take out, let's say, an average Latvian man aged 50 plus, so he is in immediate risk of developing cardiovascular event, either a stroke or myocardial infarction. So introducing a national program screening those patients and giving them preventive treatment will bring an immediate results in very few years with a very big financial and social impact, of course. This is not about healthy lifestyle yet. Here we have just a crisis which is, ongoing for many years.
Right. And similar data actually about this gender difference are coming from many post-Soviet countries, actually.
Right, yes, it's a matter also of mentality, I believe, and also the neglectance of healthcare because of some previous, ex-Soviet, as we mentioned, wounds, etc., etc. Yeah.
Thank you.
My pleasure.
So, any other questions? Yeah, one question. I will give a mic.
Yeah, thank you for this very interesting presentation. I have basically two very quick questions. One is about this inflammatory disease study. It was very interesting what you can achieve with just exercises, this reduced inflammation. How it was decided which types of exercises these people do in this group that decreased inflammation versus the placebo group? Did they both do exercises, or one was completely, lifestyle unchanged? And the second one, everyone always talks about physical exercise, healthy lifestyle. As a specialist in the field, what would you recommend for the general public that's perfectly healthy? What's the best exercises to do in a tight schedule?
Okay. So first of all, thank you for your question about this IBD study. As I've mentioned, those were abdominally targeted physical exercises. So our assumption was, and still is, that increasing the blood supply to the intestinal area might be beneficial for restoring the damage which exists in intestine in IBD patients. It was an assumption which led us to the creation of this technique. And it worked in the pilot study. And now we are starting a multi-center study in which we will discover the potential mechanisms of therapeutic approach, of therapeutic action which lead to such an improvement. Because improvement is it's not so surprising for us, but we have to prove not only the concept, but also the mechanisms. Now, regarding the other questions, your other question about what is the recommendation for physical exercises. Of course, there are common things that are good and beneficial, like walking, yes, brisk walking when your pulse is going up is actually beneficial for most of people, and it will not cause any damage for most of people. Of course, you should consult your doctor before, because if you are in risk of cardiovascular event, like we mentioned here, so getting your pulse too high can lead to myocardial infarction or whatever. But specifically to other approaches, I should say that physical activity nowadays is a very under-researched field, because let's say, if we take yoga, yes, in yoga there are approaches that are good for young people, but when they are practiced in age about 40, they will create damage. Same with aerobics. Same with going and lifting the heavy weights. It is not good for everyone. So therefore, physical activity or physical exercise should be treated like a medicine. Every person should have his own recommendation on what is good for him, and this is a goal, and this is actually a secret for allowing to this tool to be a real remedy, like it should be.
So thank you so much again.
The next speaker is Mr. Sergey Yakimenko. It's a great pleasure to introduce him to the stage. He will lecture us about investing in longevity. I think we have shown that this is a very good business, not only business, but an economical opportunity. And Sergey is actually a businessman, entrepreneur, which act as venture capital specialist. And Sergey, the floor is yours.
Right, thank you very much. First and foremost, there are two things that are especially hard to nail during the conferences, and that is my surname and the name of the fund. So we're currently 1-0 with my surname, but we're gonna correct that. So I'm not gonna lecture you, okay? I'm gonna give you a perspective on what is longevity investing, how is it different from essentially holistic science and fundamental science, and where does the difference lie in terms of the pragmatic understanding of what longevity tech, investable longevity tech is and is not. Right, so I'm Sergey. I am a co-founder and managing partner of Longevity. And what Longevity is, it's really an ecosystem now, as we realized when we were putting together the slides for this one. So the ecosystem consists of Longevity 1 and Longevity 2 that are different stage investment vehicles, where Longevity 1 deals with early stage longevity investments, and Longevity 2 is a fund, a 250 million fund out of US that is focused on later stage investments. So when we're talking later stage, we mostly mean clinical stage companies in therapeutics, as well as 30% of the portfolio is dedicated to visionary longevity tech as well. We do also have our spin-out, which is NIVC, which is a fund that focuses on animal health and animal longevity. So that one is pretty interesting, also US-based. And last but not least, the LSF, Longevity Science Foundation. So that one is a nonprofit we have established to fund super early stage fundamental science, essentially, in longevity, which is not fit for longevity investment from a VC perspective as of yet. Now, I'm going to go through a bunch of courtesy slides before, so, team, fund metrics, et cetera, because this is what you do when you're talking about the fund anyway. And then we're going to dive deeper into, what is longevity investments, what is investing in longevity to begin with. So Longevity 1, we're talking about Longevity 1 because this is the fund that is actually now kind of continuing and going towards the end of its life cycle in terms of investments. Currently stands at 17 companies in the portfolio. We do deviate from 300,000 to 1 million investment tickets into one company. I believe with follow-ups, we do have cases where we have deployed more than 1.5 million into one entity, but these are rare. So your median stands at around maybe 700,000 as of now. Geography, though, is, and this is where the bad news are, it's unfortunately not Latvia, and it's not even Europe, right? So most of our portfolio companies are US, and they are kind of evenly situated between the coasts, where it's an even proportion between Stanfords of the world and then kind of Boston-based companies. And as of now, the fund is actually pretty successful. So we stand at 3x portfolio multiplier cash on cash as of now, which kind of lands us in the upper, I think, 5% of biotech funds worldwide as of now, performance-wise. So it's pretty good. So far, we have established a lot of good friends in the industry. We have invested with Sequoia, with Merck, with Postula, bunch of pharma VCs, bunch of traded NASDAQ companies like Danaher and LabCorp, guys like Bayersdorf, et cetera. So it's been pretty well. And the fund has been around for 2.5 years now, a bit more than 2.5 years. So it's a lot of work done. Now, very quickly, people who founded the fund, and one of them you actually saw talking yesterday, Alex, who is the head of our advisory board, are actually all Latvian born and kind of Latvian raised. And this is why we're very often referred to as a Latvian fund, where in reality, geographically, unfortunately, it is not that much of a case. Now, what we are most proud of in terms of how we conduct due diligence and how we evaluate the deals that we end up investing in is, of course, our scientific advisory board. So that is kind of the core of the whole establishment. The team is also super important, right? So we run a 6-people analyst team as of now, but the scientific advisory board essentially provides key insights into evaluating science, longevity science, and translatability of science from preclinical to clinical at the later stages of due diligence. So these people are of instrumental importance for us. All of them are KOLs in their own right, in their own fields, including guys like Mike Levitt, for example, who got a Nobel Prize in Chemistry in 2013. So yeah, that's kind of how we operate, and this is the status quo of the fund as of now. With these things out of the way, let's talk about longevity in general, right? So as I told you, we kind of adopt a very pragmatic take on what longevity actually is. So for us, it's really convergence of technologies that are aimed at extending the healthy lifespan, right? Healthy lifespan is key. So it's not just let's make people younger again or living older and healthier. It's a concentrated effort, tech-wise, in order to evaluate risks, catch risks early, and prevent risks from happening that would allow us to extend the healthy lifespan. Now, a lot of people ask, like, okay, so where is the difference between biotech and longevity? Right? So what is the difference between the two industries? And if you allow joking around about this one, I would say that longevity is kind of the biotech industry that we woke up in the morning and decided that it actually has a purpose in life, right? And that purpose in life is not only dealing with age-related diseases, which is an instrumental process of longevity industry as well, but also arriving kind of at this ambiguous longevity drug and solving aging, quote unquote. Now, when you are a fund in the area, you're kind of a hostage of the rhetoric of the industry in a way, right? Because what you're looking at is this trade-off between, well, are we looking at holistic treatment of aging and solving aging as a disease? Is it a disease at all? Or we are breaking it down into actionable items, right? So are we really participating in this ambiguous quest towards a longevity drug, which does not exist and will not exist, and I do apologize for that one, for at least 25, 30 years from now. So are we looking into this, or are we rather trying to focus on low-hanging fruits, which are age-related diseases normally, and then maybe, just maybe, the sum of our successes in solving these age-related diseases would, at the end of the day, allow us to operate with some sort of a holistic understanding of what a longevity drug should be. Because a real longevity drug should be something that makes a perfectly healthy human being even healthier, right? So make something good even better. So the first disclaimer here is VCs do not invest in holistic science, right? And holistic life extension. What matters is prolonging healthy human performance through focused efforts and actionable insights. And that means that what I'm going to talk about is looking at age-related diseases primarily, and not just let's solve aging type of hypothesis, because that is not actionable, that is not sellable, and the basis of VC is come in early, sell afterwards at the multiplier, right? And it is a waste of money if you are a venture capitalist. If you are a nonprofit or a grant body, holistic understanding makes sense. Not for a VC though. So disclaimer number 2 is whenever you are a VC fund in the space, your success is kind of defined by 2 things, proprietary deal flow and analytical excellence. So you need to have best people, especially early stage, to be able to evaluate the translatability of science from preclinical to clinical. And you need to be able to participate in the deals that are really not on the market. So you need to be invited by those in the industry. You need to be able to tap into the early deal flow sharing processes with Harvard, Stanford's, Yale's, MD Andersons of the world, MITs of the world, in order to be there early with these companies. Because normally the best deals in biotech are oversubscribed before they hit the market, right? So the line of people that are willing to invest is actually much longer than the round size, unfortunately. So when we think about kind of longevity investing, I do offer you to think about it in 3 frontiers, right? Where VC kind of sits into the second one, where the first one is happening now. So this is all of your wearables, this is all of your lifestyle choices, diets, you know, the Apple Watch that says drink some water, do some sit-ups, that sort of thing, as well as supplements, which is a whole different topic about whether this is provable scientifically or not, but we're not going to get there. So that's longevity in action now. And these are your choices, lifestyle choices. Now, 5 to 10 years from the market are essentially early stage clinical therapeutics that are focused on disease-modifying therapies. And this is where the VC sits, right? So what we are primarily interested in is investing in something that modifies the disease and solves the disease or prevents it altogether. So we're not really interested in essentially symptomatic treatment of stuff, but something that would solve a specific issue. That is an unmet need. And the most obvious ones are cancer, of course, neurodegenerative, Alzheimer's, Parkinson's, dementias of the world, but also a bunch of rare diseases that are also of interest, right? Nobody has solved CKD, for example, right? So chronic kidney disease. So that's also, or IPF for that matter. So preferably, this is always platform tech. And by platform tech, you're not investing in one-trick ponies, right? So you're not investing in single asset companies where it's only one molecule, and if it fails, it fails. But you rather invest in something that is capable of producing more molecule candidates, right? That being said, you would always look for a focus in a company, but that's going to come later. And then you have the 10+ year horizon. And this is all of your visionary longevity stuff. So cryonics, rejuvenation, organ bioprinting, life preservation, longevity escape velocity hypothesis, all of the stuff that you hear about and kind of, the enthusiasts in the industry are preaching for, it's there. Normally, a VC would not invest in that, just because it's too unfocused yet and there is no market. Now, I've tried to do this exercise in our portfolio and kind of group stuff together, where on the left, you basically see the pillars that we're investing in, and on the right, the companies that we have invested in that actually kind of correspond to these pillars. Now, we distribute the fund 1. Fund 2 is a bit different, but fund 1 is the active one, so we're talking about that one. So we kind of distribute the capital across 3 major pillars: therapeutics, diagnostics and prevention, and what we call longevity infrastructure, right? So in therapeutics, well, age-related disease therapeutics, right? So we're looking at platform tech, we're looking at disease-modifying potential of certain candidates, and this is where we're looking at a combination where the company should essentially have platform potential, but should also at the same time have actual assets and actual clinical pipeline that they are willing to put through the clinic, and where they have an actual game plan to how to put through the clinic, right? And it is super important to stress that, because platform technologies without specific assets are not really interesting, because it's basically an equivalent of a teenager with good grades out of high school, but with absolutely no understanding of what he or she wants to do in life, right? So, and that is, again, not investable. And this is where we have been early movers in transient epigenetic reprogramming, for example. So Turn Bio is a Stanford company, is a good example of that. A bit of gene therapies in Marble. We've recently made our first move in the field of ADCs as a separate modality, so antibody-drug conjugates in cancer. With Katina Bio, we have been pretty early with senescent cells and senescent cell-based therapeutics with Rubido. Helix Nano is also there with mRNA therapeutics in cancer specifically. So, but you kind of get the drift, right? So disease-focused platform tech. Now, diagnostics and prevention is kind of more interesting. So this is where you are trying to understand, well, how do you catch the age-related diseases early? How do you prevent them altogether by catching them early? And how do you address patient populations that are not addressed now, right? And AOA is a good example. So AOA is the Boston-based company where we were one of the early movers in the field of blood-based ovarian cancer detection, which was not possible before due to technological limitations. So AOA is a good example. Precomp does personalized treatment selection for cancer patients. Yada, yada. The list goes on. And then the last one, longevity infrastructure, is, well, kind of answering the question of, if you want longevity drugs at the end of the day, and if you want more candidates, in molecule candidates, in age-related diseases, well, you might as well figure out how to produce these candidates faster. Not in 10 years, as it stands now for a classic kind of drug development cycle in pharma, but much faster. So how do you design them faster, validate them faster, et cetera? And this is where all the AI for drug discovery platforms, and as well as infrastructural solutions sit. Good example is, for example, Interface Biosciences. So they are a drug discovery platform in inflammatory diseases specifically that are addressing it through microbiome and certain bacteria strains and the way how metabolites in these bacteria actually affect common inflammation markers. But also guys like Glyphic Bio, where we were back in the days again, early movers in the space of single-cell protein sequencing and de novo protein sequencing. So Glyphic Bio is a 100% enabling company. They don't have, Stanford-based, they don't have an actual clinical pipeline, but they're kind of the next Illumina of the world, or at least let's hope so. So core points of attention, whenever you're investing in longevity companies, are, I try to kind of make them almost silly sounding, but I don't want to overcomplicate things for you because, well, you're not here for that, right? So you're here for an actual insight. So A, you adopt a hard definition of longevity, right? So what longevity is, and it's not let's make people younger, let's make people living longer, but what it is for you in terms of actionable items. So you should actually have a very distinct understanding of what sort of technologies you want to look at. Otherwise, longevity means nothing as a term. It's just a buzzword at this point of time. Very much as blockchain was in 2018, right? Or AI is now. AI doesn't mean anything either without the specific application. So you admire the vision, but then you evaluate hard variables, right? 80% of success with early stage therapeutic companies that we have seen are actually people, are actually, well, founders, really. And the reason for that is the biotech industry and longevity industry, by extension, is kind of blessed by having very qualified teams. So you rarely see random people actually building these companies. So you always see ex-pharma, you always see ex-research, et cetera. So it's kind of instrumental for a team to understand both the regulatory, the FDA communication, for example, as well as the R&D component, and how do you build a clinical pipeline, and how much money do you need to build a clinical pipeline altogether. So last but not least, your due diligence is mostly focused around eliminating wishful thinking. And what it means is founders, especially in the longevity field, are very fast to make long-reaching, far-reaching conclusions. And that is the company that has demonstrated, another company that has demonstrated a 25% or 30% lifespan increase in C. elegans is practically useless for a venture capitalist because it doesn't mean anything. We're very good at torturing mice and making them live longer, but then again, the translatability of this science and long-reaching conclusions of I'm going to show it in people afterwards, or I'm going to treat cancer in people the way I was treating it in mice, is a very, very, very long-reaching and far-reaching argument. So most of your time is actually eliminating wishful thinking and trying to understand, well, what's really in there in the data and how translatable the base science is into clinic, potentially, because you're going to stay with the company when they enter at least phase 1. I mean, if you're an early stage investor, you enter preclinically, and then phase 1 or beginning of phase 2, you try to exit. We already talked about the fourth one, so short-term focus, long-term platform potential, and that is assets in the clinic, actual definable pipeline, yet potential to actually produce more drugs, right? And not be a one-trick pony. And then the most important resource that you can give your portfolio is, of course, network, right? So access to clinical infrastructure, access to early, later stage investors, and kind of, be there to support them, also with the scientific advisory board efforts as well. Now, some of the challenges that you're facing, and we're going to go bottom up, is first and foremost, a lot of funds in the space are kind of trying to differentiate themselves in terms of, okay, so what am I really investing in when it comes to therapeutics? Because diagnostics is easy. I mean, it's early diagnostics. You either do it or you don't. In therapeutics, it's a bit of a more complicated game where, are you investing in NCEs? So are you only looking at new chemical entities? Are you looking at combination drugs, right? Are you looking at generic combination drugs? Because there is a market for those as well. So are you having proprietary IP as the mandatory checklist on your due diligence, or are you kind of, you're more flexible in that regard? Are you looking at specific modalities? A lot of VCs in biotech, and there are very few VCs in longevity because very few people actually understand that, but in biotech, sometimes you see funds investing only in certain modalities, only in gene therapies, or only in small molecules, or antibodies, or there are funds that are exclusively looking at ADCs, which is the hottest market in oncology right now, antibody drug conjugates, which essentially allows you to So the ADC stands for essentially your ability to glue together an antibody and drug molecule. And then you get targeted delivery, and then you get the targeted cytotoxicity of a drug molecule without the systemic effect and kind of just wasting the whole patient, right? So all of these choices you're facing. Now, prior overvaluations is another plague that the industry has kind of experienced and lived through, right? We are seeing a lot of companies that raised their rounds at a significantly higher valuations of what they were supposed to be raising, right? And we see overvalued companies that cannot sustain their fundraising effort. They cannot get more expensive, and they are facing down rounds. They are facing additional founder dilution. And eventually, a lot of good science and a lot of good companies become uninvestable because of that, right? Because the founders were diluted, and the company is not capable of raising the next round at a decent valuation, and then there is no money to continue. Or the clinical milestones were not met yet, so there was no value inflection point, yet the money is out in the bank as well. Research expertise not matched with business acumen, kind of already talked about that, yada, yada. And then last but not least, regulatory. So with regulatory, again, I do not support, and I'm being very upfront with it, I do not support the usual rhetoric of saying, well, we cannot do anything because FDA doesn't understand aging. Aging is not an endpoint, so we cannot do anything. And if FDA starts speaking that language, well, this is where we're going to change the world. Well, that's BS. Not going to happen, right? So FDA is there for a reason, and then the existing clinical trial framework is there for a reason. So instead of trying to advocate for aging as a separate endpoint in clinical trials, which we might as well have at some point of time, you rather take your longevity tech, which is a platform tech and fundamental tech, and try to pinpoint it to a certain disease indication where you can actually prove its worth. And that's the only way in the industry right now. And that is the only way to earn money with these as an investor, and that's the only way to actually, for them to reach the patient. Because otherwise, we're stuck in this platform, holistic, talking around about how it's gonna be great to solve aging, and we're not moving anywhere. Last but not least, I do have a few slides to kind of demonstrate the point here. So what are the key value inflection milestones for the companies in longevity and in biotech in general, right? So first and foremost, the holy grail is strategic partnerships with pharma. And there is no better example than your own example, so we just pulled together a few companies out of our portfolio that have those to give you kind of a glimpse of how it looks. On Nature Products, for example, which is a, they are developing macrocycles, just partnered with Merck for 220 mil partnership, which in pharma terms usually means an upfront payment and then a milestone payment. And they're cooking up another one for 500 million with one of the top 5. Now, Turn Bio, the epigenetic reprogramming people that I told you about, one of our early investments, just partnered with Hanal Biopharma, Korean pharma, 300 million in the whole kind of contract value. Hot AI, a skin aging and skin analytics company out of Estonia, actually, has Beiersdorf, Chanel, Ulta, a bunch of other institutionals as their key clients. Katina, our first move in Katina Biosciences, I believe is the full name. Our first move in the antibody drug conjugate space in cancer, just signed a couple. So Amgen, Roche, and Sanofi are all, I cannot disclose the deal amounts, but these are kind of in the portfolio already. And the company at this point is in preclinical stage. So sometimes in hot areas such as ADCs, you get preclinical stage companies already striking pharma partnerships. Now, the other key value inflection milestone whenever you're investing is co-investor pool and institutional investors that you have on board, because these are people that are ultimately going to buy the company that you're investing in. And this is where, you know, good examples are, for example, Cyfox, which is a blood testing company, consumer-focused blood testing company, where we invested together with Intel, Y Combinator, Khosla. A very good example of institutionals joining in the companies early is, of course, AOA. So the ovarian cancer people pretty early got pre-A round, got Danaher and LabCorp. Both are NASDAQ-traded diagnostic companies as their early investors. And that is usually your kind of indication of them buying you if everything is well. And then last but not least, a bit more of a big names, Marvel Therapeutics. We joined together with Sequoia, Mayfield, Bald, etc. So I'm going to leave you with this example here, which is Rubido. And that is a perfect illustration of the company that I think represents the new generation and the new age of what a longevity company should be. Rubido is a company in the senescent cell space with the key differentiator that they actually figured out different types of senescent cells that are typical to different diseases and different processes. So the senescent cell for them is no longer a holistic kind of umbrella term, but they can differentiate those and they can remove those selectively without off-target effects, and they actually moved into human clinics just recently with the lead program in atopic dermatitis and the second program in IPF. So we'll see how it goes, but it is a very good example. Just signed with Bayersdorf, what's interesting. A very good example of what a longevity company should transform itself into to be investable. And that's pretty much it from me. I hope that was at least somewhat helpful. But the main message here is you always search for something actionable, right? Where you understand how this will reach patients and in which time frame. You weed out wishful thinking, and you try to think about the longevity drug and kind of the longevity breakthrough, not as a North Star somewhere there without actual understanding of how to get there, but try to go one by one. You try to address age-related diseases. You try to understand the underlying processes of these diseases better, and then maybe, just maybe, the sum of these understandings will lead you to ultimately getting a longevity drug out there. Yeah, thank you very much. Hope that was helpful.
Thank you so much for this exciting presentation of how money brings a difference and how proper funding allows us to move this so much important field. Please, any question from the audience, please?
I have a question. Thank you. I like your saying that we have to avoid the wishful thinking, but how can you convince us that it's not the bubble which is which will blow up probably in 5 years?
Bubble meaning longevity tech?
Yeah, all promises, which probably are too optimistic sometimes.
Yeah, promises are, I mean, it's a bit like marriage, right? So it starts with promises, and then you need to deliver, and if you don't deliver, then off you go. So same here. I think if you go by data, and you make reasonable assumptions of whether this data will be translatable or not, you're good, right? The point that I'm trying to make is, whenever bubble is created, and that is not only for longevity, right? So that is pretty much for anything. So whenever bubble is created, this is where the economic activity and investment activity and money pouring is based only on assumptions with no data to back them up. So, and this is why, I mean, AI is a bubble right now as well, right? So a lot of these companies will die because they will not find an actual application. And we have a lot of these examples across history. So I think in longevity tech, if you go by actual preclinical data, or even better, clinical data that is validatable, you're good to go. Because ultimately, it does not differ from any sort of biotech out there, but it just doesn't, right? It's the same pattern. You have a hypothesis to prove, you have a disease indication, or you have a mechanism of action that you want to prove, and then how do you prove it? Well, with reliable, independent preclinical and clinical studies, right? And if you don't have those, a lot of investors would still join you, I guess, but really, if you want to stay out of the bubble, you just go by the data. That's it.
Thank you. One more question. Can you explain, please, in current situation, the research on new therapeutic agents on longevity, health longevity, is mostly driven by the private funding, or there is also the involvement of the institutions, bigger institutions like Big Pharma, or maybe even the governments?
Yeah, well, that depends on what you call healthy longevity, right? So big pharma, let's demystify big pharma for a bit, right? So big pharma wants assets. An asset is an identifiable thing, small molecule, whatever the modality is, that has a certain mechanism of action and a certain market and patient population to address. Full stop. This is where pharma ends, right? So whenever it fits in their ballpark, yes, pharma actually started to join rounds much earlier. Before that, they were just, I mean, they were lazy. They were buying assets out of phase 2 clinical trials, so like well into the human phase. That's it. Right now, they can join preclinical. So that's one thing. Then you have VCs, but VCs also need something identifiable and kind of some sort of understanding of how this reaches the market, right? Then you have nonprofits, so all the grant money of the world that funds basic longevity research. So researching basic aging processes that might or might not end up in certain therapeutics one day, or a certain like identifiable mechanism that we're looking at. And these are also private, like I've just mentioned Longevity Science Foundation, so it's a private endeavor, right? These are public, so in US, National Cancer Institute does actually a lot of fundamental science funding in longevity. That might have cancer as a disease target applications later, but this doesn't have now. Then you have huge government-backed, yet like quasi-private initiatives, such as Evolution, right? So Evolution is a $2 billion foundation, which is backed by the Saudi government, Saudi crown prince, pretty much, right? They also have a VC arm, but realistically, they're also, most of their work is distributing grants. So it's a blend. Right? It's a blend. And the blend differs, and kind of the actors that are involved differ as the company progresses from very vague understanding of what it wants to do into something tangible, right? And then, you know, more money comes in. What I also invite you to think about is that pharma per se is still not really interested in platform technologies as such, without actual assets. And I think maybe Alex told you about that yesterday during his talk on in silico medicine, right? But the only way of how a platform company survives right now is having this bundle proposition of, yeah, being able to create, let's say, new molecules, et cetera, but also having its own pipeline, right? Own therapeutic candidates that they're pushing, most promising ones normally, that they're pushing to clinic. And this is where you blend these strategies, and this is where you're interesting to big pharma.
Thanks a lot for this so much important and comprehensive overview.
Thank you.
So we are about to finish our first session, but before we go, we would like to thank for the support and sponsorships from our sponsor, namely Baltic organization, Longevity, Betterlin Lab, Longcell, and Nordic Laboratories. Your support is very, very beneficial, and it would be hard to gather this meeting without your important support. So sponsors, thank you very much for letting us progress on this important topic. So now we invite you to the first floor, actually mine is first floor, to, yes, Ilya? It's on, yeah.
Is it? All right, so I'll just start by saying that this is an exciting space for companies to work in. I didn't hear the whole of the last presentation, but it was impressive to see the amount of investment that is going into this healthcare environment. We're seeing that patients in particular are starting to realize that health is a finite asset, and they're going to start investing in it. As practitioners, we need to find the right tools to be able to support them, to get them to achieve that healthier lifespan, or what do you call it, health span, I think is the correct terminology for that. Nordic Laboratories has been in operation for about 25 years now. I'd like to think that we've pioneered a lot into this space, supporting practitioners in about 65 countries, where providing access to functional medicine, or depending on what you call it, integrative medicine, functional medicine, preventative medicine, you'll eventually run out of names as to what to call that. But that's where we've been active in the last 25 years, allowing practitioners to order tests that conventional medicine might have raised their eyebrows at, thinking why are we doing these crazy things that are not that are not accepted by general practice. So the standard of care has changed. This is where we operate. So we'd like you to come through and chat to us, find out a little bit more about what we do, how we can help you as a practitioner or as a patient even, figuring out what impressive and valuable tools there are that can change lifestyles, change longevity, change the way that we develop illness and hopefully prevent illness.
My name is Susa, and I'm the sales representative at Nordic Labs, and I actually live in Finland, where we have our genetic lab, and I operate here in the Baltic countries. And during recent years, I've been very happy to see the rise in understanding of the holistic view, supporting people's health and help them live healthily longer. And I'm very happy to have you introduce you to some of our products and tests at our stand here. And please also feel welcome to register to receive our newsletters. We offer a lot of supporting services like free training, also some paid big conferences internationally. And we would welcome you to come and see what's available as a tool to provide the best possible care as a practitioner to your clients and patients. And feel welcome to raise any questions to us. And yes, so very nice to have been here. We are actually, hopefully, planning an event in Riga this year. We will see if that takes place. So also by registering with us, we will inform you of our future events. Thank you very much.
So you're welcome to join us in the lunch break, minus first floor. And Ilya, please.
Thank you very much, Yuri. Thank you very much, Valdis, for the chairmanship, and thanks to Nordic Labs, thanks to Longevity, Sergey, thanks to us, to Vetic Association, the Movement for Longevity and Quality of Life in Israel. So thanks to all the sponsors who make it possible, and hopefully will make similar events possible in the future. And just to add to what Yuri said about the lunch, yes, welcome to go to the -1 floor for the lunch. And also after this session, after the next session, which will start in about half an hour, let's have another post-meeting reception where we can have even more food. So once again, thanks. And even now, if some of the new speakers can join for a group photo, that could be great for the second day. Valdis, especially Sergey, if you're still here. Thank you very much for all who remained. They're the strongest will to live for the longest time. And we start the last session of our conference. which has been going great so far, if I may say so myself. The next speaker is Dr. Bat-Sheva Porat Katz, who is from Israel, like me, with the Hebrew University of Jerusalem, and she will tell about preventive medicine in older adults, the Israeli experience. Unfortunately, she couldn't come here in person, so she sent a recording. So please plug in Bat-Sheva. Welcome. Is Bat-Sheva's video ready? Yeah. Problem with the sound, guys.
The sound is okay. Good afternoon. My name is Bat-Sheva Katz. I'm a physician specialized in internal medicine, in geriatrics and psychogeriatrics. I want to thank the organizer, especially Yuri, for giving me the opportunity to share my experience from my private practice as well as my experience as a head of the geriatric in one of the Israeli health maintenance organizations, the HMO. I will now begin with a small challenge. Please check with yourself, how old do you feel? Remember the number you set. Please compare this number with the number written in your passport. Usually, the numbers are not identical. Most of us feel younger than the age written in the official documents. This can lead us to the question, how do you define old age? And another question to be discussed, at what age would you describe a person as old? Here are some of the answers I got from my distinguished colleagues to the question, how do you define old age? They suggested retired age. Professor Schoenfeld, who you heard yesterday, says everything is autoimmune until proven otherwise. Einstein said everything is relative. So I adopted his idea, and personally, I think that everyone that is older than me are old, and everyone that are younger than me are young. So as I age, my definition for old age move up. But seriously, after a philosophical discussion with my colleague, we agreed that medical age is a good definition. Old age can be defined as decline of reserves, losing the reserves, physical, mental, and other. When looking at this picture, most of us gravitate towards the young child, hoping in our heart to resemble her youth and wishing to delay our aging processes. Unfortunately, we have yet to discover the knowledge of how to freeze time, though some of you might be on the break. Currently, aging is a physiological process that is unavoiding in spite of our best efforts. Yet, even though we can't change the fact that all of us are aging, and we all have already aged at least 3 minutes since the lecture began, we can still try to postpone the presentation of old age morbidity. This is a rationale of our intervention that I will present here. We all wish to know the direction to longevity. So how can we obtain longevity? The study of longevity is intricated as an formality. There is no one simple answer, but we can identify several cornerstones while assessing our patient. When exploring the genoepidemiology of aging, Israel is known in have one of the longest life expectancy in the world, ranking as number 9 in the planet with an average age expectancy of 83 years. Ranking at the top of the list is Japan, with an astonishing 84.5 average life expectancy. In a study conducted on centenarians, which are individuals who reached 100 years old, it was found that most of them share a sense of purpose, which correlate to the Japanese notion of ikigai, which means in Japanese, having a reason for living. The most intensive part of the puzzle, the physical and mental status of the patient, which are interconnected to each other. When the brain is sick, the rest of the body quickly follows and vice versa. Another key part in the pursuing youth and longevity is social interaction. Family connection play a significant role in one's hope of reaching old age. Previous data have highlighted the connection between close family relationship and life expectancy. Marital status, sibling, and offspring all play a prominent role. Additionally, studies have also suggested companionship and close friends as an important prognostic factor, with an emphasis on quality versus quantity. Lastly, in the famous song, "It's All About Money." Just kidding. There are other elements, but sadly, money does play a significant part in our chance to reach longevity and its effect span of life. But the salutogenic model as a theory to guide health prominent by Aaron Antonovsky was established in 1992. Salutogenosis is a study of the origin of health and focus on factors that support human health as well-being, rather than on focus that on the cause of the disease. As we see here, we see the flow of the river, and we have the upstream, midstream, and downstream. We can try to affect those places by trying to intervene And on the next slide, we can see how it's best done. We have the primary prevention, secondary prevention, and tertiary prevention. Here we can see health in the river of life. At the beginning, on the shore, it's promotion. Later on, we have health education, prevention, and protection. But then when we are down the river, we can go back. We can just try to heal and try to the situation to help. So quality of life and well-being is important. The deviation of the disease care system is to saving swimmers drowning downstream by chronic measures rather than asking who or what is pushing them into the river in the first place. On the conceptual level, health promotion is linked to the WHO vision of health is a state of optimal physical, mental, and social well-being, and not merely the absence of disease and infirmity. The concept of health promotion is surely attractive and has given birth to some bright idea. My way of action to focus attention on curative medicine downstream, that is one part of my work, and disease prevention upstream effort alike. So the upstream, I'll try to demonstrate what we have done in Israel. Curative medicine is devoted to those who are drowning. Preventive medicine to those that in danger or being pushed into the river upstream. And health promotion to all of them, especially to those who are safely on shore. The focus of Israeli statistics, when we focus on the Israeli statistics, the elderly declined as those aged 65 and above, constituting of 12% of the general population, which is approximately 1 million people. In the HMO, where I worked as the head of the geriatrics, there were approximately 125,000 patients over the age 65 and above. As you can see in this cake, the young old defined those age 65 to 75, accounted for 65% of the patient. The middle age group between 75 and 84 years old composed 27% of the patient. Lastly, the very old patient, which were 85 years and above, made up only 8% of the patient. And by using special selected categories, we sift the population according to age and physical condition. Patients were grouped as follows. And this allows us the ability to investigate an intervention in consider healthy patient, because in this way we could identify the healthy patient we have according to the age, and to try to affect their outcome as with the best we can. The intervention. We recruited a team of a team of employees, retired employees, and they help us in the intervention. The patients were defined by risk factor according to age and physical status. The different columns represent the physical status ranging from healthy to morbid, and the various age groups. Each tab represents a different stratified risk for morbidity, and numerous of intervention opportunity were allowed to different groups. Based on this analysis of the healthy population, we included an intervention, starting from the oldest healthy population and later on to young and healthy patients. In order to conduct the intervention, we recruited volunteers from a pool of retired healthcare professionals. The volunteers approached the healthy patient and enlisted them. After recruiting, each patient filled a questionnaire designed by us, surveying different morbidity and clinical symptoms. Following the first step, each patient met with his physician caregiver, which led to individualized medical recommendation and intervention. After the recommendations were done, the volunteers reminded actively and were assigned to induce patients to fulfill the medical recruitment. So what we did here is, first of all, the follow-up to know that the people are doing what was recommended, because we knew we are dealing with people that don't come to the doctor, usually don't need anything, or and so if there were things that in the 1 hour meeting with a GP was found as needed treatment, we wanted to be sure that they are encouraged to do it and not just getting the recommendation, putting them aside as often it's happened in the practice. The other main thing was here, the GPs had there were lectures showing them how to think in the geriatric way and inquiring different things that usually are forgotten to us because you think they are too small significantly. Just like if there are any candida anywhere in the groove, in the body, and knowing that that's entry later on in life for cellulitis, erysipelas, and preventing this severe morbidity in the elderly, and or asking about constipation or sleep habit, and that's helped in a way, or not only for those chosen patient, but also in the GP training, so he could use it as well. And another gain we had is recruitment team retired health employees that had a meaning now, and also heard doing the survey, they heard about all kinds of unimportant, sort of unimportant things that should be treated to prevent severe morbidity. And so we gained those things by, and what we saw, the questionnaire revealed that patients suffered from severe complaint regarding eating, pain, sleep disturbances, constipation, worthlessness, and depression. As I mentioned before, those were sort of healthy people that didn't reach out for their GP. Each complaint was an opportunity for intervention with great impact on patient health and aging process. For example, eating disorder are frequently linked to protein energy malnutrition resulting from chronic energy intake reduction, leading to reduced body weight and altered body composition. A nutritional approach based on the supplements with mixture of essential amino acid has proven efficiency in conditions characterized by reduced dietary intake and increased degradation of endogenous proteins, and might also contribute to correct the amino acid deficiency possibly involving in the pathogenesis of eating disorder. Sleep is a basic need that we share with all the animal kingdom. We all need to sleep, so each animal does it differently. Some animals sleep while some animals sleep while standing up, and the albatrosses even sleep while bleeding. The basic need is often interrupted by our modern way of life, with constant flying and nighttime shifts interrupting the natural circadian clock and sleep timing. Another example on the most common complaint, one of the most common complaints that we have seen is the sleeping disturbances with impact cognition, depression, general mood rage, and impatience. Maintaining good quality of sleep and full sleep cycle is essential. We commonly diagnose sleep apnea following a patient complaining regarding a slight memory decline. Early diagnosis and treatment of obstructive sleep apnea can prevent a great deal of morbidity. I want to finish with this photo illustrating our life journey from the bottle perspective. As we go through life, each age group has its own distinctive bottle. Thank you for listening.
Maybe one question from the audience to Bat-Sheva, if you have. If no, then please, let's introduce the next speaker.
Dear longevity friends, do you know that half of our cells does not contain our DNA? So, because we have DNA from viruses, bacteria, fungi, etc. So, and the main question, how this impact our free will? And I will introduce to Laima Kimse, and she will explain more about this problem. The stage is yours.
Study explores the tiny organisms in our body and how they could positively affect our mental health. So these are the key sections I will be talking about today, and let's start. So why this is an important topic? According to the World Health Organization, prior to pandemic, more than 917 million people worldwide were affected by mental health disorders. From these numbers, 33 had anxiety disorders, and 21 were suffering from depressive disorders. And the prevalence of mental disorders has remained stable, approximately 14%. And more than 55 million people worldwide are affected by dementia. Dementia rates as the 7th leading cause of death and is a major cause of disability dependency among older adults. So new therapeutic approaches are essential to alleviate the burden of these disorders. So how could we do this? Human gut microbe consists of over than 100 trillion microorganisms. And these include bacteria, archaea, viruses, and eukaryotic microbes. And they play important roles in human body. They maintain gut integrity and epithelial shape. They gather energy. They prevent pathogen invasion. They control host immunity, and they synthesize neurotransmitter production. They also regulate cortisol levels and produce short-chain fatty acids, which are essential for intestinal health. So if there's any shift in microbial composition of the microbiota, this is called dysbiosis. And if there is a dysbiosis, then it can activate the hypothalamic pituitary adrenal axis, release cortisol, and lead to increased intestinal permeability. And the compromised integrity of the gastrointestinal tract or leaky gut allows the bacteria to migrate and cause inflammation. Dysbiosis also alters levels of transmitters such as serotonin, dopamine, and glutamate. And it also disrupts vagus nerve signaling. And if the inflammatory cytokines disrupt the blood-brain barrier, this permits the immune cells to infiltrate the brain and cause neuroinflammation. And it can lead to neurodegeneration. It has been found that patients with different mental illnesses, such as depression, bipolar disorder, schizophrenia, and autism spectrum disorder, have significantly varied gut microbiomes. And interesting fact is that research on Alzheimer's disease indicates that dysbiosis leads to abnormal protein aggregation in the brain, inflammation, immune dysregulation, and decreased neuronal and synaptic activity. So what can we do to correct this dysbiosis? One of the ways is to use probiotics. The term probiotics originates from Latin and Greek, and it translates to meaning for life. These are foods and supplements containing non-pathogenic microbes, usually bacteria and yeasts, which inhabit the gut and may offer numerous health advantages. The most often used genera are Lactobacillus, Bifidobacterium, and Enterococcus species. And these probiotics have been used to prevent and treat illnesses such as intestinal diseases, for example, antibiotic-associated diarrhea, traveler's diarrhea, irritable bowel syndromes, and others. Also, they can be used to treat cardiovascular and urogenital infections. There has been studies for their use in cancer treatments, lactose intolerance, cystic fibrosis, and oral diseases. So, psychobiotics are defined as live bacteria or probiotics that, when ingested in adequate amounts, have a positive effects on nervous system through the interaction with gut microbiota. If the consumption of psychobiotics has a positive effect on correcting microbiota dysbiosis, and they can also alleviate symptoms of central nervous system disorders such as insomnia, depression, diabetic neuropathy, anorexia nervosa, autism spectrum disorders, Parkinson's disease, and multiple sclerosis. But these are just few of these illnesses. So the effects of psychobiotics are mediated by the gut-brain axis. It is a bidirectional communication network connecting the enteric and central nervous system. And these include anatomical, endocrine, humoral, metabolic, and immune routes of communication. And these routes allow the brain to impact intestinal activities and vice versa, allows the gut to impact mental health, mood, and cognition. And these communication pathways are made of a vagus nerve, hypothalamic pituitary adrenal axis, enteric nervous system, endocrine cells, immune cells, and microbiota with its metabolites. So, how does probiotics work in human body? They can reduce stress-induced HPA reactions. They decrease corticosteroid stress reactivity. They also increase neurotransmitter synthesis. They produce essential short-chain fatty acids, which are essential for gut barriers integrity. They enhance brain-derived neotropic factor, which is significant for brain development, and they also can stimulate the secretion of gut hormone peptides. They also limit the pro-inflammatory cytokine production and inflammation, and they can trigger the vagal anti-inflammatory reflex, which leads to the production of acetylcholine, which thereby prevents the tissue damage of excessive cytokine release. So, next I will tell you about a few of these diseases, depression and anxiety. It is a prevalent psychological disorder among adults. The underlying mechanisms are unknown, but it is found that these involve imbalances in serotonin-ergic, noradrenergic, and dopamine-ergic processes, and are often linked to deficiencies in serotonin and norepinephrine functions. That's why the first-line antidepressants, which are used for patients, inhibit the reuptake of these biological amines. But the problem is that in many cases, patients develop resistance to these antidepressants, so it is necessary to search for new types of therapy options. Investigations in clinical trials and animal studies with targeted bacterial strains demonstrate enhancements in depression, anxiety, and associated symptoms. These mechanisms could possibly involve the production of short-chain fatty acids, anti-inflammatory substances, modulation of neurotransmitter synthesis and metabolism, and also HPA axis modulation. A recent systemic review and meta-analysis analyzed 42 clinical trials to compare the effectiveness of antidepressants and probiotics in treating major depressive disorder. And the results suggest that probiotics could be effective as either an adjunct or standalone therapy for managing major depressive disorder. Next is Parkinson's disease. It is a chronic progressive idiopathic neurodegenerative disorder characterized by both motor and non-motor symptoms. It is the second most common neurodegenerative disease, and it affects middle-aged and elderly population. The pathology behind this is a loss of dopaminergic neurons in the substantia nigra and the accumulation of alpha-synuclein forming Lewy bodies and neurites. And there is an interesting hypothesis that Parkinson's disease starts in the gut and spreads to the brain via the vagus nerve. This is supported by the evidence that alpha-synuclein deposits were found in the gut before the presentation of motor symptoms. Clinical trials and animal studies have shown improvements in common non-motor symptoms of Parkinson's disease. For example, improvements in stool consistency, reduced bloating, reduced abdominal pain, and increased spontaneous bowel movements. It also had decreased scores of Movement Disorder Society's Unified Parkinson's Disease Rating Scale. It is a scale that measures the severity and progression of Parkinson's disease. These studies showed improved gait, balance, and coordination. And there were also changes in metabolic parameters. Next is Alzheimer's disease. Alzheimer's disease is a chronic neurodegenerative disorder. It leads to the memory loss and cognitive decline and is the most prevalent form of dementia. The key pathological features include formation of amyloid plaques and neurofibrillary tangles. And these features cause synapse and nerve cells loss, leading to brain atrophy. Despite extensive research, the exact mechanism remains unclear, but studies suggest that gut microbiota, dysbiosis and changes in gut and blood-brain barriers permeability may influence the onset of Alzheimer's disease. And the gut microbes can also produce substances like amyloids and lipopolysaccharides, and these substances affect signaling pathways and trigger the production of pro-inflammatory cytokines associated with Alzheimer's disease. Studies done on animals have demonstrated enhancements in cognitive function, inflammation reduction, acetylcholine level restoration, and mitigation of oxidative stress and neuroinflammation. Clinical trials on humans have shown improvements in cognitive function as measured by the mini mental state examination score, improvements in memory, visual, spatial abilities, and language skills. There were also positive changes in metabolic profiles, including reduced inflammation markers, increased antioxidant capacity, and improvements in lipid and insulin levels. In summary, I want to tell you that research findings highlights the potential of psychobiotics as novel interventions for mental health treatment, but further investigations into their mechanisms and clinical applications are necessary to maximize the therapeutic advantages of psychobiotics. Thank you for your attention.
Thank you for interesting presentation. And please, questions? Please.
Thank you very much for the nice overview of this fascinating world of microbiota and probiotics. First of all, do you have any specific candidates of specific strains which do act as potent psychobiotics?
Yes, there are few candidates, but not something specific that shows very promising results. There are. I'm sorry. Okay.
More questions? So I have one question. We are living in a very interesting country. We have sauerkraut. And how do you think it will help?
Sauerkraut?
Yes.
Yes, I think sauerkraut and other fermented foods like kefir or yogurt can help to prevent gut dysbiosis, and therefore they prevent illnesses such as mental health disorders.
Thank you. Okay, thank you, Laima.
Okay, thank you.
So, and some years ago, we can't imagine that we will very easily use artificial intelligence, for example, ChatGPT, and now Emil Syundyukov will present the ideas about artificial intelligence and other things. The floor is yours.
Thank you.
Hi everyone. Sorry, I will just put my accessory here so it doesn't look like a longevity expert, maybe with the crutches, but nevertheless. Okay, so we will have it on screen in some time, I think. And we're gonna start in a second. So
try to push a few more times. It should work. Oh, yeah.
Ah, perfect. Good. So thank you for the introduction. So I will not be a common longevity presenter here. I'm a computer scientist by education, but I work in healthcare. And I will be talking rather not only about the AI, but basically about the digital technologies and how can it shape and connect two islands between the R&D or also, the drugs and therapies that are on the market and the broader population in the sense of diagnosed and also healthy diagnosed patients, healthy population. So just quickly about the background, computer scientist here, so I work with data, I know how data flows and how to make sense out of data. for the last decade or so, I work with different academic and industrial research projects in healthcare in different therapeutic areas. Also co-chair of Digital Health Council at the Ministry of Health in Latvia. Yeah, I represent the company, so we made a company eventually, you know, in parallel doing research in academic sphere called Longenesis. We're the leading one in Baltic states, working on patient engagement in different therapeutic areas, 800,000 patients that we engaged. 2 national projects on our shoulder. We're the largest one in Baltics and having traction in the Middle East and EU as such. So working with different therapeutic areas, and you will see in the examples in the next slides how do we enable patient engagement to support post-launch of different therapies, as well as, you know, making sense out of data, as I might say, to support the patient journey, but mainly focusing on oncology, cardiometabolic, and neurology, but having other therapeutic areas on our shoulders as well. We also do publish, so feel free, there will be a QR code. You can also learn more about our research. There's just a portion of articles here, but I will not stop there. I will switch to the keynote topic. So I think previous presenters during 2 days conference, they were talking a lot about, you know, how to increase the amount of research to prove, to have data, to have more evidence to support novel therapies, diagnostic methods, and so on. But basically, how can we build a bridge between the lab and R&D developing novel methods and the broader population itself? And I truly believe that digital technology is the way to go there, especially if we're talking about the broader population, which are not in the healthcare facilities 24/7. And the problem that we're focusing is not only about lab and R&D, but also on existing therapies. Even there, the problem still stays and still is quite important. So it takes, you know, more than 500 days for a post-launch, so basically after the launch and registration of the market authorization of the drug to become available in EU member states countries. So it's a lot of time, especially taking into account that there are years and years in R&D beforehand that. And the thing that, you know, we're focusing, the challenges that we see where digital can help is, you know, there is a need of innovative ways to identify eligible patients through multi-omics data analysis as an example. We should strengthen the post-launch studies. We should embrace the post-launch studies to strengthen the reimbursement claims so the drugs and therapies that your dear colleagues or other peers are developing and bringing to the market are there for the patients. And also, how can we increase the patient adherence to the protocols? Because it's not a secret that is a big challenge. And, you know, by, as an example here, by McKinsey, up to 60% of patients are not compliant to the protocol. So, I mentioned this state, so we need more research and more evidence. And if we look into longevity, and I think Sergey beforehand today was talking about that, you know, we should focus more on different therapeutic areas rather than, you know, just having in a more meta sense of, you know, longevity as it is. We should tackle different diseases at different stages. We are looking at the patient journey, very simplified. You know, it looks much harder, much more complex. But I would like to give you several examples how we apply digital technologies in several pathways and several episodes of patient journey. And I hope it might be of sense for you who are the ones validating or developing the therapies. And let's start with prevention and screening. I think Yuri was presenting from Riga Strategy University about, you know, launching, and during the Q&A session talking about that we should have a more of a multidisciplinary approach to engage broader population. So men in Latvia, and not only in Latvia, are living longer, but it's not only about men. And for sure, there is a screening strategy. We all know about the screening. It's widely used. We should identify patient at risk or patient at its early stages of diseases and then, you know, guide them through diagnostics and further patient journey stuff. And just an example, don't read the text. It's in Latvian. I will just explain as an example. So in Latvia, we have also screening campaigns. And it's not the only country in the world. A lot of countries have it. And as an example, it's based on the age. There is certain periodic manner when patients receive something like this. And, you know, my mom received this invitation a year ago, and I reread it 3 times to understand basically what she needs to do. Yeah, and, you know, and I'm kind of connected to this year, so it was rather challenging. And what we see is not only, you know, the empathy of rereading this stuff and trying to catch these people and engage them, but rather we see this in the numbers. It's not good. We should reach 70% plus of the screening engagement rates, to make it successful in the end of the day. But the numbers are here for 3 types of screenings: cervix, colon, and breast. And just to put it here, so Mary Claire King from University of Washington stated that, if we identify a patient as a carrier only after the patient develops cancer, it is a failure of cancer prevention. So we should speak about preventative strategies even beforehand identifying the thing. But we meet a black box, am I right? So we cannot just, deploy the doctors on the streets and catch people, and try to diagnose them or, question them or engage them in any strategies. We should think of something else. And what we did, just a couple of examples to give you a sense of how we do this with digital tech, is several examples there. First and foremost, COVID-19. So we launched a study with the Holon Institute of Technology in Israel and Boston University and Postula Clinical University Hospital here in Riga, back in the days to engage broader population in COVID-19 risk stratification. Back in 2020, we used Chartier model from Johns Hopkins University and identified and basically provide a strata of a group of population from Latvia and other countries. So we engaged in 1 month, we engaged more than 2,000 patients in the study. And then by providing strata, we'll launch another questionnaire on vaccination readiness. Basically, the data that we compiled and brought to the policymaker was that we can personalize the communication strategy, not just have a banner on the street here near the National Library of Latvia stating get vaccinated or die, or whatever bold move we put there on poster, but rather personalize it based on the concerns, based on the lifestyle, based on the phenotype, based on other maybe comorbidities and other aspects that patients might have. And another example, speaking of oncology screening, since I was putting on the previous slides, is breast cancer. And the stats are not good, so we tried to experiment with that 3 years ago. We started with a direct population engagement to boost the awareness and personalize the risk assessment for women in Latvia. We engaged in a couple of months 10,000 participants in different municipalities. So on a personal level, it means that patients have their own personalized review, the report, that they can basically turn it back to the GP, gynecologist, or any other practitioner related to the disease and talk about that. But on the meta level, what we did, we extrapolated metadata and showed it to municipalities, stating that, as an example, in the municipality of Liepāja, they had hundreds of women who have had family history, but no specialist talked with them about that. And basically could personalize the strategy of prevention care right away. You can scan it to participate if you would like. We'll launch another campaign on cervical cancer in Baltics in 1.5 months in partnering with MSD and Marek. So happy to have you on board if you wish. And how we do this, basically, how do we engage broader population? And we surveyed around 6,000 participants throughout the studies, why they took part in that, like why, do they have enough free time just, just to scroll and do some stuff, whatever it is. And 2 aspects that they outlined. The first one is engagement through personalization. If you have ever participated in the study, you most probably have seen, the questionnaire of 60, 70 questions, and then what you receive backward is basically, thank you for your participation. You're gladly contributing to the future of science. We changed the paradigm a bit, so what the participants received in the breast cancer is a personalized report, meaning that it's actionable data for them. They can use it. And it's not about the generic woman in Latvia, but it's about certain person who can use it as a call to action. And the second part is building trust with patients in empathy-centric research. A lot of them answered that what they liked is the level of understanding for what purposes, where, how the data is being used, and they can manage it. And we built the first one, and we are the first in Baltics to launch digital dynamic e-consent for the clinical research, starting for the genomic trials in breast cancer. And basically, so it means that I'm from my mobile phone can control and receive invitations to the studies. We have a layer of granularity. I can see what modalities of data are being used for certain studies. And it's not a whip for the researchers, it's rather an enabler. We've seen higher number of participants because of that. And the example is not only about Latvia. I think the good example is also the Emirates. So for 4 years, from Latvia, we support the Emirati Genome Program. So They aim to provide a full genome sequencing for the whole population, connect this data to phenotype and medical records, and basically, in the end of the day, create the preventative strategies and the personalized medicine on a country level. So the Minister of Health of Latvia visited together with us the site last year. Coming forward with the diagnostics. Diagnostics, once again, so I think the colleague from Israel told that there are a lot of people who are not coming to the healthcare facility. So the only ones who come, we can diagnose them, and we have different, different protocols and abilities. And I will put the example that we'll launch a study in Baltics for cardiovascular diseases. Sorry, it's in Latvia, and I will explain what we're doing there together with the virtual hospital and the Post-Strategic Clinical University Hospital as a physical hospital there. So what we launched with digitized SCORE2 OP model from European Society of Cardiology, meaning that patients are being stratified by the algorithm and being engaged in a questionnaire, and then they're being proposed to have an online consultation with a cardiologist. But it doesn't end there. So it's cool that you have, it's not cool that you have high risk, but basically you put high risk, then you have a consultation, what's next? So build a dynamic model to basically see not only the starting point of the SCORE2 risk, but rather than, where the patient should be. So the aim level of the SCORE2 or, risk calculator. So the doctor of the consultation can click on different recommendations and we can monitor dynamically the patient with him being at home or, remotely. So we can see how he fluctuates towards the aim goal. Example of the treatment, and both at home and at hospital treatment, the same black box comes there, especially for chronic conditions. Patients are not staying in the hospital all the time. They're being referred to GP, they're at home, receiving care there, remotely, physically, at any level. And this is just an example I wanted to put here from hemophilia patients. So we visited one of the healthcare facilities, the Children's Hospital here in other countries, and what they give to patients is this diary. So once they visit the hospital afterwards in 4 months, patients should fill in this thing. So imagine it's fully filled in. Could you read this in your 15 or 20 minutes consultation to better understand how to personalize the treatment? I bet it would be hard. And basically it means that we should have a shift from unstructured data to structured data to support both the treatment protocols as well as the research, because in the end of the day we need to have a supportive data for market access. And what we did, we basically digitized this for patient, parents, and children, meaning that at any point of time, based on the protocol, they can fill this in, and what patients see and what the doctors see, you will see on the next slides. The same we did with market access, oral contraception. 1 month, 2,500 participants took part in understanding and busting the myth related to contraception, but basically we received very valuable data for the market access for novel drug. And just as a last example before I finish, to the summary to show you what HCP sees, because I assume the question will be who's going to use it in the end of the day, another system, wow, is early breast cancer. We'll launch it together with Stratnich Hospital, who's a great partner of this conference, a digital pathway and support program for patients, meaning that patients coming to the clinical nurse now receive a printout like this, basically, where they have contacts, from Kaplan, nutrition stuff, physical activity, et cetera, and they're frustrated. What they do, they call the nurse once again and once again. What we do, basically, we digitize this pathway, so by scanning the QR code, they receive an SMS with 1 click, they have access to personalized educational materials based on the pathway, but we can collect PROM, and we use an ICHOM methodology here to collect patient-reported outcomes, to open this up for HCPs, meaning that they have the whole department on the whole patient flow there. They can review the data if needed, but the thing, what they like is also visualization for sure. We can triage patients, and we have also predictive model outcomes to better understand that in the long run, how patient will fluctuate towards the aim goal or towards something bad in terms of adherence, as an example. But to finalize, the thing that, it works in one hospital setting or with broader population, but if we talk about research, it's about collaboration, am I right? So there are different healthcare practitioners here in the auditorium, most probably online as well, and how can we collaborate? Because it's not about Latvian sites, Israeli sites, Finnish sites, it's about combination of multicentric approach. And how can we do this? Because we cannot just open up the data and put this in one box, am I right? Like last year, I took part in the European Oncology Consortium here in Riga, and for 3 hours we were arguing who will hold the data. because there were participants from Germany, Slovenia, Spain, Latvia, Estonia, and no one said that, hey, I will just give my data to you, because it's illegal in the end of the day, it's hard. So what we built a tool that's used by around 80 different sites is called Curator. Basically, they can showcase their data reach or patient reach without data leaving the hospital. Data stays local, and this gives us an opportunity to open up the patient and data reach from Emirates sites, South Korea, Latvia, Spain, Germany, France, and other countries of the world. And basically it means that researchers like you can hop on the platform, have access, and do not only the review to engage someone, like as a type of diabetes cohort as an example here, but you can also provide strata, real-time stratification to actually identify patients of needs for your research, if you're running any also longevity trials as an example. Meaning that we have a combination of different sites working hand in hand, fortunately, towards novel treatment protocols and novel methodologies to support patients. And for sure, also Strata is provided by the AI algorithm that just asked me to talk about AI. The last slide is about AI, is how to navigate through fragmented data. We can do real-time strata of patients, basically meaning that you enter the inclusion criteria here, and our algorithm can run through laboratory information system, radiology information system, EHR, EMRs of the world in one healthcare setting, and give you the cohort size in the end of the day. Finalizing, thank you so much, and yeah, be happy to talk. If you have any questions about digital tech, I'm here to talk with you. Please contact us. Thank you.
Thank you, Emil. Thank you. And do you have questions? So I have one provocative question. Yesterday we had a discussion, and the question is, will the artificial intelligence and digital technologies replace the doctor?
That's a very good question. And I think, I think it was GE Healthcare CEO who told that it's not about, doctors versus AI. It's about doctors using AI versus doctors not using AI. So that's, the same like crutches, if I wouldn't I wouldn't have them, I would be very much slow and painful, am I right? This is the support tool for me. The same as AI. And I really encourage not to, fear the AI or any digital tools, but rather use it, because you guys are using laptops. I see a couple of, clinicians there in the auditorium using laptops. It's the same thing, basically to help you navigate faster and do what you need to do, treat patients.
Thank you, Emil.
Thank you.
Thank you very much, Emil. And we are getting close to the end of this conference. And one last presentation is from Lika Levskaya, who is one of the co-founders of the Longevity Alliance Baltic, played a critical role actually in establishing this association together with Gleb Centners. And she will present also about quite an important, I would say, critical topic of psychological and social aspects of longevity promotion. And that's important. Longevity Alliance Baltic and longevity movement, longevity advocacy generally is not just about, or not only about advancing scientific studies, scientific reporting, but also about building the longevity ecosystem that would support such research. That people would even become interested in extending their longevity, their healthy longevity. They become interested in technology, in research. For that, you need also psychological motivation and social determinants. And that's the topic that will be addressed by Lika. So happy to collaborate in this, and then we'll finish. Please plug in.
Hello and welcome to Longevity Alliance Baltic. Second edition. My name is Lika Levskaya, and I would like to present on psychological factors of longevity today. A little bit about myself. I'm a clinical psychologist with a little over 21 years of experience. And as I would like to say, that I'm trudging on the road to happiness and helping my clients to do exactly the same, hopefully successfully. And I'm also on the mission to help people understand their minds better so they can make better choices that will lead to a better life. So today I would like to share some
fascinating research on topic of psychology of longevity. And let me show you what are we going to talk today about. So we're going to cover some important questions, Big 5 personality test in relation to longevity, concepts of healthy aging and systematic review of theoretical models, psychiatry and longevity, very hot topic, blue zones, and so what we can do now to live a happier and longer life in terms of psychology, psychology of longevity. Here's very important questions to ponder. Why do individuals desire longer lives? How will extending human life will impact our understanding of life purpose? How will personal identity evolve over centuries of life? How will longevity affect relationship between generations? What psychological and behavioral aspects contribute to longevity? While these questions are deep and they're very important and very philosophical in nature, it's great to ponder upon them. At least I think so. Today we'll try to answer on the question of what psychological and behavioral aspects contribute to longevity. I will gonna present, to my taste, a very interesting collection of facts, research facts, and hopefully we'll collect an interesting summary in the end. So we all have different personalities. Some of us extroverts, social butterflies, but some of us are introverts that prefer staying at home. However, the Big 5 personality test is widely used in psychology, social science research, as well as in applied settings such as career counseling, employee selection, and so on. So let's go quickly over the personality traits that are being researched. Openness to experience, conscientiousness, extraversion, agreeableness, and neuroticism. While all of these personality traits are very important in terms of longevity and research and testing, one of them definitely stands out in terms of longevity. So conscientiousness is one of the Big 5 personality traits, a widely used framework for understanding human personality. It is important in terms of longevity and health according to a large body of research. And it's so important that we're going to spend a little more time, extended time, talking about that. So let's define what is conscientiousness. It's people who have great skills in organization, they're disciplined, they're goal-oriented, they have a good self-control, and they're reliable. So what we have found very important in longitudinal studies that followed individuals for over 2 decades and demonstrated a clear link in between childhood conscientiousness and longer lifespan later in life. The meta-analysis 2008 by Kern and Friedman suggests that strongly supported a positive association between conscientiousness and longevity. In this study, there was over 8,000 participants. Large cohort study, Turiana 2020, integrated data from over 44,000 participants, again revealing a consistent pattern. Higher conscientiousness predicted a lower risk of death. There's possible explanation, the health behavior risk. One study found a connection between childhood conscientiousness and healthier adult behaviors, like let's say people had a reduced smoking in adulthood. And sleep connection, also in the study in 2019, suggests that conscientiousness may influence longevity through sleep patterns. Their 20-year study observed lower conscientiousness predicted increased death risk partially through the effect of shorter sleep duration. Interesting. There's potentially biological findings and biological reasons. Sullivan in 2021 explored the link between personality and immune function. Their study found that lower levels of interleukin-6, a inflammation marker, in individuals with higher conscientiousness. This suggests a potential explanation for their longer lifespans. So we know inflammation, inflammaging, things like that. Metabolic health, also one study examined personality and various health markers. So there's definitely a biological link related to longevity and conscientiousness. So the good news that we're, as a people, we're not set in stones, and let's say for some reason we lack that trait, we can always train, we can always learn. So there's definitely hope for us. So the next slide is going to be a little bit dry, a little bit technical, but bear with me because this is a very important information. And as a matter of fact, I will use this meta-analysis, the recent paper by Marilyn Minasa as of 2023 to use a theoretical foundation for my dissertation, so it's important to me. There's some quick takeouts. Out of total of 10,700 records examined, there were analyzed 59 papers. These papers encompassed 65 aging models and definition of human aging. So what was found? There's intrinsic and extrinsic factors were identified as an interacting throughout of life course shaping the aging process. Three main models were identified, synthesized. Type 1 model, health outcomes, emphasizes extending healthy lifespan by reducing disease and disability. Type 2, adaptations, focuses on lifelong adaptive processes to maintain quality of life. And type 3, adaptations and health outcomes, integrates with type 1 and type 2, promoting resilience and well-being. There's actually two subtypes. I'm gonna go quickly over subtype 2, person-environment congruence, stresses alignment between individual and environmental factors. And subtype 3, health promotion, highlights activities to enhance resilience and well-being. So in this slide, let's see a link between psychiatry and longevity, and let's just talk generally about our well-being, and that feeling good on the inside helps us living longer, happier, obviously happier lives. So we're gonna refer again to a large meta-analysis that analyzed 109 studies from 24 countries. So the outcome is this: people with any kind of mental disorders lose on average 14.7 years of their lifespan compared to general population. People with schizophrenia and bipolar disorders probably around the same, which is 12 to 15 years. Very sad news that people who have a substance abuse problems lose the largest, which is 20 years out of their life in general. Men have lower life expectancy than women. We're also talking about the same target population, which is have mental disorders. And so many years lost to unnatural causes, for example, like committing suicide, obviously compared to natural causes. So What is the good news? Well, the good news is we have a control over our lives, and let's say if unfortunately we do have some diagnosed or not diagnosed mental health disorder, there is definitely help. We can talk to a psychologist, we can talk to a psychiatrist, we can seek treatment and work on ourselves, and there's a power to change. So there's amazing places called blue zones where people live super long, happy, perhaps lives. We're talking about centenarians and super centenarians. What it means is people that live over 100 years old. And there's a recent Netflix series that I believe have 3 series covering the study and following these people, and it's a very nice series that I definitely recommend to watch. But let's see where located these amazing zones. One is Loma Linda, California. The other one is Nicoya, Costa Rica, Sardinia, Italy, Ikaria, Greece, in Okinawa, Japan. So what are these 9 lifestyle changes or 9 habits that have been recorded as possibly the main contributor to a longer life and lifespan? So the first one is move naturally. There's no suggestion for a structured exercise. What is important is regularity and natural physical activities like gardening and housework. Purpose of life in Japan, it's called Ikigai, and in Nicoya it's called Plan de Vida. Well, it looks like it can add up to 7 years of life, so that's very important. Downshift, no stress or reduction of stress. There's prayers that used, prayer Adventist and napping. Ikiranians do that, and happy hour in Sardinia. So those are practices in stress reduction. 80% rule, which is very interesting. In Japan, it's called Hara Hachibu, which means stop eating when you're 80% full. Very good to remember. So we have plant food focus. So diet centered on beans and limited meat consumption. Mostly pork. Meat servings 3 to 4 ounces, 5 times a month. So not completely vegans, but definitely reducing the amount of meat we're consuming. Wine at 5. Moderate regular alcohol consumption. I believe it's wine, nothing else. 1 to 2 glasses per day with friends or food. That's for people who engage in alcoholic behavior, let's say, or like to have fun. Or for people who doesn't have, I think we can all take resveratrol or things like that. Sense of belonging, number 7. Membership in faith-based communities, attending services 4 times per month. Interestingly, but adds from 4 to 14 years of life expectancy. Number 8, loved ones first. So we prioritize family, keeping aging parents nearby, committing to life partners, investing in children. So family is very, very important. And the last one, 9, right tribe. Social circles that support healthy behaviors. In example, Okinawians, Moyas, groups of lifelong friends. So those are the main 9 things that I guess we can utilize and integrate in our lives. As a psychologist, I am heavily invested in studying any factors, psychological factors, social behaviors related to longevity. Well, obviously for my professional use and personal use. So there's few more things that the study and large body of research suggests that could contribute to a healthier and longer life. And we talked about conscientiousness in length, though we're not going to talk about that anymore. But the next one stands purpose in life, and that is, we have some very interesting and encouraging data about that suggests that people who have a purpose have mortality reduced almost by 50%. Greater purpose lowers stroke incidence among older adults. Japanese study shows ikigai significantly reduces mortality rates. Purpose in life is essential for well-being and health outcomes. And Viktor Frankl logotherapy highlights meaning pursuit for resilience and survival. That's something very interesting book, and I suggest everyone to read that one. Self-efficacy stands on the third place, suggests that one's ability to succeed or believe in one's ability to succeed significantly impacts longevity. Bandura 1997 work established self-efficacy is crucial for health outcomes. So there's a lot of actually studies on self-efficacy and longevity and health. Obviously, the next one is healthy behaviors, something that we all know about, that exercising, eating healthy, taking vitamins and things like that will definitely help us live longer and healthier. Sleep patterns, we all know there's a lot of research on sleeping and recovering and DNA repair and things like that. Social connectedness, something that also was mentioned in Blue Zone's presentation. Strong social connections and sense of belonging can positively impact health and longevity. The next one, we have positive emotionality, a tendency to experience and express positive emotions like joy, gratitude, and contentment is linked to a better health outcome and potentially longevity. Also, a study that mentioned in my references list, all of this data and statistic that I give you listed on my reference list, and if somebody interested to maybe dive and read all of these articles that mentioned in this presentation, please send an email. I'm more than happy to send you this presentation for your use and suggestions and perhaps education and things like that. Optimism and positive outlook, well, it's self-explanatory. A tendency to express positive emotions, and managing a positive outlook is effectively managing stress and may contribute to a longer lifespan. I am obsessed about solutions, so I created this slide to just remind ourselves that, let's say if we don't have certain traits or certain behaviors, or we have the behaviors that are not contributing to our health and longevity, there's always a way we can take control of our lives and change that. So there's plenty of information online, and psychologists, the people have tricks up their sleeves, so it's definitely an option. But let's go quickly over some perhaps very simple, obvious, but important nonetheless. Building your ikigai, the purpose of life. Create a vision to integrate your purpose into your life, and the good way to test whether it's a good purpose of life or not, to ask yourself why, right? So why am I compelled to follow this dream or follow that purpose of life? Number two is enhance conscientiousness. So that's something we can do, very simple things. We can become more organized, use daily planner for task organization, set specific achievable goals and track the progress. Build self-efficacy, set and achieve even small goals and manageable goals, and always praise ourselves. That's a good way, motivation to keep going. Cultivate optimism, maintaining gratitude journal. And I have to say something about that. I've seen miracles. This little journaling, and especially emotional journaling, exercise creates miracles, even though it's very simple. Adopt healthy behaviors. Well, enough been said in this conference about healthy behaviors and health and supplements and interventions. So regular exercise, taking supplements, healthy eating, it's all gonna do a good thing. Enhance social connectedness, reconnect with friends and family, so family number one. Participate in the community activities, volunteer at our organization. It's a good way to connect, right? So that's a good way. We will be super happy to have you as a member of our organization. Foster positive outlook and resilience, meditation, mindfulness meditation, engage in positive psychology exercises like gratitude and acts of kindness. So as simple as it sounds, it's very efficient in achieving longer life and definitely more and better quality of life. Thank you so much for listening, and just remember, living a great life, it's not about only living longer, it's also about joy, it's about purpose, it's about family, it's about all the finer things in life. It's an enjoyment of life. So I would like to say thank you again, and if anything of this material, if of interest to you, as I mentioned before, I'm happy to send the reference, this presentation, and my email is lika.levskaya with a J @longevitygroup.eu. So I would be happy to get your emails, and thank you so much and have an amazing day.